Good morning. I'm Mike Nardolilli. I'm the Executive Director of the Interstate Commission on the Potomac River Basin, or ICPRB, and I would like to welcome everyone to the 2023 Potomac River Conference, where I'll be moderating the opening session. I'd like to thank the Planning Committee that have put together this second annual installment of this series. Renee Barassa, Heidi Moltz, and Cherie Schultz. Thank all of them for their hard work. This year's event will focus on One River's perspective on a changing climate. And funding for this conference has been provided through a Section 106 grant from the EPA. We'd like to dedicate this conference to our friend and colleague, Curtis Dalpra, who joined ICPRB in 1981 and passed away earlier this year. We're going to hear more about Curtis Dalpra's legacy of stewardship at lunch. First up, I'd like to introduce Jamie Hedges. Jamie is the General Manager of Fairfax Water, Virginia's largest water utility, producing water of exceptional quality for over 2 million residents of Northern Virginia. She leads a workforce of 475 to directly serve over 1 million residents of Fairfax County, cities of Falls Church and parts of Fairfax, and indirectly serve 1 million residents in neighboring jurisdictions through 7 wholesale utility partners. She received a BS in Civil Engineering and a Master of Business Administration, both from Virginia Tech, and is a licensed professional engineer in Virginia. She has been recipient of the George Mason University of Civil Engineering Institute's Engineering Excellence and Leadership Award and the Meritorious Public Service Award from the area's Council of Engineering Companies. For more on her impressive background, I direct you to the conference booklet, which many of you have seen up front. But I would like to add just one more thing, which is just thanks, Jamie, for the use of the hall. so with that, ladies and gentlemen, Jamie.
Is this? I'll use. So welcome everybody. It's great to see such a large crowd of folks who are interested in one of my favorite resources, the Potomac River. We're really happy to be able to host you all here today at our Griffith Water Treatment Plant. This plant was constructed in the early 2000s to replace some older plants that were located nearby in order to be able to meet new and changing EPA drinking water regulations. It is sourced by the Occoquan Reservoir, which is located nearby, and can produce up to 120 million gallons a day. For those of you who enjoy a little bit of history, first thing in the morning, it is located on the site of the former Lorton Reformatory that was run by the District of Columbia. The architecture on the buildings takes its inspiration from those historic buildings and located across the street. In the older former buildings from the 1900s is the Lorton Arts Foundation. So I encourage you when you're next in the neighborhood to take a trip over there as well. Looking to the future, this facility is also going to be sourced from our Stephen T. Edgman Reservoir, which is a unique project that we've entered into with Vulcan Materials, where they're in the process now of mining a rock quarry located between this facility and the Occoquan Reservoir. It is an active mining operation, so I've been asked to let you know that we may have a blast at 1:30 this afternoon. Vulcan may have a blast. It can be a little unsettling. So just, if you're a little unsettled around 1:30, that's why, and hopefully you'll remember that. Our other treatment plant is our Corvallis treatment plant. It's located up in Herndon, and it is sourced by the Potomac River and can treat about 225 million gallons a day. It is the largest treatment plant in Virginia. And these two plants combined produce 345 million gallons a day. And as Mike mentioned earlier, we today serve nearly 1 in 4 Virginians. Over 2 million people receive treated water from one of these two facilities. So we're very, very proud of that. Very proud and humbled because it is a huge responsibility to be providing a life essential service to that many people. So I know everybody in the room today has a vested interest in the Potomac, and certainly Fairfax Water shares that interest. As an area water provider, the Potomac is essential to our mission, not just ours, but other water utilities in the region. I saw Aladdin Water and probably a few other water utilities using the Potomac that are here today. So combined, it's a drinking water source for nearly 6 million people in the region. And as you all know, the provision of water service is essential to public health and safety. It really is the foundational building block to having high quality life and vitality in your economy, in our community. Abundant, high quality water that flows every time you open a tap or open a fire hydrant doesn't just happen. It requires the stewardship of our water resources, our infrastructure, and our finances to provide drinking water, safe drinking water, and fire protection to our community. And in our business, we don't focus just on what's going on today, although that's a large part of our focus. All the folks here and the folks up at Corvallis, making sure the water's getting out to customers. But we also have to focus on decades of tomorrows. That's why we're working on the Edgemond Quarry next door. That's why we work with folks at ICPRB and our colleagues in Washington and Maryland to make sure there's enough water supply for the future. We have been very fortunate to have a long-standing relationship with staff at ICPRB. I just wanted to mention Cherie, Schultz, who we've worked with for many, many years on our water supply planning for the region. They've been a great technical resource and very much appreciate all of their efforts. And I know the conference that ICPRB staff has put together today is going to bring together a lot of different perspectives, a lot of different research on various aspects of the Potomac. I think you've got a great program ahead of you. You know, we all cherish the Potomac and we all want to make sure we know what's going on, and we're doing everything we can to make sure that it continues to be a vital resource for the region for generations to come. So enjoy your day. And just be on the lookout for that little rumbling at 1:30 this afternoon.
So your conference booklet details the impressive resume of our planned next speaker. Bob Sussman, our outgoing chair of ICPRB, wanted to be here this morning but had another commitment. He asked me to express his excitement about this conference and the broad cross-section of government leaders and experts who have come together to discuss issues of broad importance to the Potomac River Basin and the large population it sustains. He said, quote, "While climate change poses big issues for the planet, we are increasingly seeing that the impacts vary from one region to another, and we need to be understood as a function of changes in weather patterns, water supplies, plant species, wildlife, land use, agriculture, and other unique local conditions. Decision makers and planners need to understand these factors and, despite uncertainties, develop models that enable us to predict the consequences. Will there be more rainfall or less? How will aquatic life be affected? Will the mix of crops change? What areas are most vulnerable to flooding and extreme weather events? Is there a greater risk of drought? Today's conference will help us start to answer these important questions." And he says, "Speaking on behalf of my fellow commissioners, I wanted to express appreciation for the tremendous effort by the staff to organize this conference and for the rewarding dialogue and information sharing that I will know will take place over the course of the day." But we have a real speaker here right now, and we're going to hear from our keynote speaker. Katie Blackman is the Vice President of Programs and Operations at the Potomac Conservancy, where she ensures the programmatic alignment of the Conservancy's land conservation, policy, and community conservation departments with the organization's Clean Potomac Plan. Katie also directs the Conservancy's diversity, equity, inclusion, and justice efforts, including the management of the organization's internal DEIJ working groups and board committees. Katie has a BA from UMBC in history and elementary education and a master's degree from King's College of London in tourism, environment, and development with a concentration on volunteer ecotourism. Again, I would like to direct you to the conference booklet for more information about Katie, including how she is an avid sourdough baker made with Potomac River tap water, of course. Ladies and gentlemen, Katie Blackman.
Thank you very much for that introduction, and thank you to the ICPRB for inviting me to come and be your keynote speaker today. You know, it's probably no surprise to anyone in this room to hear that an entire day talking about the local impacts of the climate crisis on our river could be a bit of a downer, right? Those of us who spend our days working on these issues know that the climate crisis is here and the climate crisis is now. This is not new information for us. But for many of our friends and neighbors, the signs that climate change is not just something that's happening over there, but something happening in our own backyards is just starting to fall into sharper relief. Our summers are hotter, our rains more intense, but far less frequent. And just this summer, we all broke out our masks again, but outside this time, as wildfire from fires in Canada, the smoke from wildfires in Canada made the air in Maryland dangerous to breathe. At Potomac Conservancy, we spend a lot of our time talking to people outside of our sector about the clean water issues that matter to them the most. And we're starting to see, as you can see here, over time, there is a growing concern about the local effects of the changing climate. Our climate report, Rising to the Challenge, a New Climate Reality in the Potomac River Region, takes these local impacts and breaks them down into these 6 sections. We guide audiences through a complex web of compounding effects of the climate crisis and try to give audiences concrete actions they can take to be a part of the solutions. We guided them through these sobering key facts. Extreme storms and longer droughts are now our new norm. By 2100, much of Washington, D.C. could be permanently underwater. Summers could be insufferable in our region by mid-century. The Potomac River is rising rapidly at twice the global rate. Climate triggers are increasing Lyme disease, asthma, and allergy. Brook trout, hemlock, and wood thrush may not survive. See, a bit of a downer. We painted a clear, if somewhat bleak, picture of what our region could look like in the coming decades. But it's really hard to inspire action when you have just thoroughly bummed people out. So we tried to balance these dire warnings with examples of actions communities are taking, or with calls to action that readers could take, directly relevant to the sections they just explored. We also felt that it was essential to spend significant time looking at the community impacts of the climate crisis, especially as related to public health and environmental justice. As we know, communities most marginalized by our society, especially as compounded by intersecting identities of race, economic status, and more, bear a far greater burden of the climate crisis than that of their more privileged neighbors. Our report laid out the impacts to health, like an increase in tick-borne disease, a rise in allergy and asthma symptoms linked to heat, intense storms, and floods causing blooms of fungal spores. We also outlined other air and water quality issues that make the climate crisis not just an environmental issue, but an issue of life and death, and especially for those communities that our society has most marginalized. With significant input from the Community Engagement, Environmental Justice, and Health Center, we also dove deep onto issues of climate justice. Throughout the U.S., communities of color and low-income communities are statistically far more likely to have environmental burdens sited near them. In the Potomac watershed, this is a direct result of a racist past, including redlining, and whose legacies are still felt in permitting and zoning practices today. Our report described a brief history of the environmental justice movement from its roots in the environmental and the civil rights movements to its evolution to a climate justice movement. We highlighted local communities affected by the impacts of environmental racism, which was only exacerbated by the climate crisis. It's important to note that Potomac Conservancy is a historically predominantly white organization, and our roots are not in these frontline communities. So we therefore had to rely on the knowledge and action of others for this section of our report. We shared the stories of local communities impacted by the impacts of environmental racism, like the story of Buzzard Point, an 83% African-American community in a low-lying neighborhood in Southwest DC. They have fiercely advocated for years to clean up pollution from road traffic, concrete facilities, power plants, stadiums, not to mention flood-proof that low-lying community. When the calls were answered in the form of flood-proof infrastructure and residential units, community members are now turning their fight to being able to afford to stay as affordable private housing supplies are being replaced. We covered the story of Brandywine, Maryland, an unincorporated, predominantly Black town whose lack of representation has led to shocking exploitation. 3 power plants, one of which is coal-fired, and 2 planned gas-fired plants all exist within a 13-mile radius. And you add to that a coal ash landfill next to the only community playground, a sludge lagoon, concrete batching facility, a Superfund site, a different mining operation that uses explosives, and heavy diesel traffic. Community activists are attempting to stop this onslaught in court, but without political representation, it is a hard battle. And these are not examples of a shameful past. These are happening today, and they're happening mere miles from where we are. We also highlighted the story of the new Community Project Climate Farm in Mount Clinton, Virginia, as an example of a climate justice solution being led by those most impacted by the climate crisis. And in this case, climate refugee populations who hold traditional ecological knowledge of regenerative agricultural practices from their home countries. This 6-acre farm is serving as a research center for carbon farming and food production in the Shenandoah Valley. Our report concluded with concrete climate solutions. We reflected on the 7 key findings from the series and explored how nature-powered solutions can help us overcome this crisis. Anecdotally, I've seen the shift from the most frequently asked question going from, what can we do to stop the climate crisis, to what can I do to be ready for what's coming next? And my answer to both of those questions is the same. And it's the same whether you are my neighbor who's been farming the field next to my house for generations, or if you're one of the brilliant experts in this room who's taking a science-based approach to this greatest challenge of our lifetime. And my answer is this. Okay, so my answer is not to go home and stress eat an entire plate of Chips Ahoy. But I will say, if that is your form of self-care, please do it, because Lord knows we can all use joy wherever we can find it, right? But no, my answer is to take this plate of cookies to a neighbor you've never met. Because I believe, in the face of the climate crisis, the single most important thing that we can do is build community where community is missing and strengthen community where community exists. I believe this to be the most important thing for 2 main reasons. The first is that individual action alone is not going to change the course of the climate crisis. We know this, and it's beyond time we stop putting the onus on individual people. I can show up to my county council meeting as Katie Blackman, party of one, and make a pretty compelling argument, especially considering the line of work that I'm in. But I would be so much more effective at advocating for green infrastructure, or stream restoration, or funding for reforestation projects if I show up with the backing of my community. Headlines will tell us that polarization, especially among political lines, is dividing Americans at greater rates than ever before. And many organizations, mine included, spend a lot of our time, and it is necessary time, figuring out how to communicate across lines of difference. But if we build community, we can stop trying to communicate. I can speak loud enough. I used to be a teacher. But if we build community, we can stop trying to communicate across lines of difference and start communicating through lines of trust. By building community with a shared vision for a future where we thrive, not just survive. We are more powerful. I'm good without it. We're more powerful, and it's often a missing piece of our climate mitigation strategy. The New Local is a UK think tank that focuses on community action, and they point out in their report on communities and climate change that local action that's rooted in community need is often more responsive to changing conditions, has inherent legitimacy with local people, and is able to facilitate adaptation strategies in context better than national or global efforts. The other reason that I believe in building communities, as noted environmentalist Bill McKibbins points out, in our new climate reality, we're going to need each other. He says, we've come through 75 years where having neighbors was essentially optional. If you had a credit card, you could get everything you needed dropped off at your front door. The next 75 years aren't going to be like that. We're going to need to return to the basic human experience of relying on the people around us. For many of us in modern society, we've become more isolated. The Pew Research Center has found that the majority of Americans either don't know their neighbors or know them, but don't talk to them. And this is especially true if you live in suburban or urban communities, or if you are Black or Latino. Now, it's important to note that this is not just attributed to individual lifestyle choice. Systemic oppression has divided communities and sometimes literally and eroded trust. But nevertheless, this lack of trust in the people that live around us makes us more vulnerable when the worst happens. And the worst is happening here. Remember this really cheery slide from earlier? And there we go. And remember this day in 2019, where folks were stranded on top of their car on Canal Road in DC when we got a month's worth of rain in just 3 hours. We need strong, place-based communities to depend on in an ever more uncertain and dangerous future. But where do you start? So I say you go back to that plate of cookies. Last year, my husband and I took a walk on our street, and we were feeling really frustrated about a lack of community in our very small neighborhood. And suddenly we both stopped and we looked at each other, and it was just this light bulb moment where we're like, communities are just groups of people, and we are people. So if we want community, we have to be the ones to build that. So the next day, we went around and we dropped off a note and a little plate of cookies in our neighbors' mailboxes in all the streets surrounding our house, inviting them for a gathering every second Saturday of the month at our home. No pressure, no agenda, just space to be together in community. And 1 year later, it's working. Second Saturdays are now neighborhood parlance, something that we're all looking forward to each month. We share food and drinks and laugh and information, but we're also building relationships and trust. We're building connections with people where connections didn't exist before, and the word's spreading. And it feels like every month somebody else who we didn't know lived right down the road from us is showing up. Together, we're building a community of people who can rely on one another for something as simple as, to use a not so hypothetical situation from earlier this week, calling your neighbor and saying, I'm running late from work, please go to my house and meet my kid on the bus. True story. Or for when the worst happens. We're building the kind of place where we don't question where to go when one of our wells runs dry or when our homes flood. We're building the place where we know when there's extreme heat, which neighbor is vulnerable and doesn't have air conditioning. Or when the next pandemic forces us to close our doors again, we know who's going to need help getting food and medicine. We can be ready with the strength of connected communities for whatever the climate crisis throws at us next. And it's going to throw a lot at us. So as you go through this amazing lineup that ICPRB has set up for you today, it may feel really overwhelming knowing where to start. So I urge you to start with community, because we don't have to do this work alone. And in fact, we can't do this work alone. It doesn't have to be hard. It can even be fun, and it can all start with a plate of cookies. Thank you.
at twice the national rate. What does that mean? I mean, if I walk across the night, so
There you go. So
I said, what does that mean? I think I could walk across it anywhere if I go up the stream far enough. So what do you mean it's rising at twice the rate?
So he's asking, what do we mean when we say the Potomac is rising at twice the global rate? So when we're looking at the rise of the Potomac, we've already seen it rise feet. So not just inches, but the Potomac has risen by feet. And we are predicting that the Potomac will rise by the height of a mailbox, of a US mailbox, by I think 2100, which means that places, it doesn't just rise because water needs boundaries. So that means it's going to start flooding those areas. So when we're saying that, for example, by 2100, much of DC may be permanently underwater, that's where that water rise goes. It goes out, right?
So you're measuring at the tidal Potomac is where you're taking this measure?
Yes. And we have some really good experts in the room today who can probably answer that question as well.
We didn't hear that question.
He was asking, when we say that that it's rising, what does that really mean?
Does it mean sea level rise
It's actually the level of the Potomac, and we're measuring it in the tidal portion.
at a certain stage gauge?
So I will say, I'm probably not the best person to answer like specific questions about where this is being measured, but we do probably have people in the room today who do those measurements. So if there's anyone else who'd like to, so the question there was, is there a specific stage gauge where we're measuring these things, or how is that being measured?
Well, I think from our modeling, and Cherie can correct me if I'm wrong, it shows that the Potomac Basin over time is going to get wetter and hotter. Unfortunately, though, it's going to be more variable. The wet years will be wetter and the dry years will be drier. So we'll have this fluctuation, which we've not had in the past.
I don't have a question per se, but I'd like to say that what you and your husband have decided to do is pretty amazing. I live in a neighborhood where I know my next door neighbor and my across the street neighbor really well. We get together a lot, but I don't know the rest of the neighborhood. And kudos to you and your husband for actually sticking your neck out and, trying to make a difference. That's all I gotta say.
Thank you. I will say, both he and I felt like, is this going to be the thing where we invite everyone to our birthday party and no one shows up? We have about 30 people who come regularly, and the guest list is 50. And it's growing all the time. And the thing about making it appointment, you come or you don't, we'll be here, kind of relieves some of that, will you join me at the dance pressure that we all feel.
And I'm sure it's BYOB, right?
Yes.
Testing.
Thank you very much for that presentation. And I do think that DUI issues are very much neglected in the environmental field. And one thing I'd like to promote is we need to do all we can to get underrepresented minorities into the environmental field, because that's one of the ways that you actually do make a change. People in the community see people that look like them, and that makes it so much easier for them to make an impact. It's not a bunch of, as you say, white folks coming in to try to help them. So, and that's one problem in my field. I mean, I'm Chris Jones. I'm a professor at George Mason, one of the things I'm trying to do, even with my own money, is to help support, to help offer scholarships to underrepresented minorities to go into the environmental field. So I think that's one of the ways we can really make a positive difference.
And I'll just add that
Thanks, Chris.
that's important. Making sure who's in the room, who's making the decisions is a really important piece of it. But it's also really important to not assume that those leaders in those communities are not there now. So, and what we really learned in the examples that we highlighted is there are environmental activists and environmental justice activists who were born and raised in Buzzard Point or in Brandywine, who are the ones really pushing forward this work. So as people in positions of power and privilege like that we have by the nature of the fields that we're in or the jobs that we hold, finding those folks who are in their community and leading the charge and figuring out how we can support the efforts that they're leading in the ways that they need us to is a really powerful way that the people in this room can help.
I did have a question. What is your opinion of the 11th Street Bridge project in Anacostia?
So we don't have, I would just say for Potomac Conservancy, we work on the Anacostia with groups who are headquartered in the Anacostia and who focus solely on that river. We've been supportive of the 11th Street Bridge project. Do people know what that is? So it is turning essentially a bridge into a community park. And it's being led by a lot of community activists in the Anacostia region. And it's been a good example, I think, of supporting community action to bringing green spaces to neighborhoods that may not have them.
And I would just add that one of the things that they were concerned about is that you have this investment in this park, and that has a tendency to gentrify the neighborhood around it. And so the idea is that you didn't want to push the people out who would benefit from this park. And so they had a very, what I think a unique approach was actually to hire people in the neighborhood to be ambassadors for this project. So they would get buy-in from the local community, and hopefully people can stay around to actually enjoy the park once it's completed. Testing.
Thank you. Ms. Blackman, I'm really moved by your presentation. I'm Veronica Tangiri, and I work with the Prince William Soil and Water Conservation District. Actually, I studied in Sweden, but I'm working with the district with the knowledge I gained in Sweden. And I believe, your presentation has really moved me because I have been in Prince William County for 8 years where I've been working with the district. And I remember when I came to Prince William, what I wanted to do, I needed the blessings of the people. And I remember very well visiting Professor Jones in George Mason University to tell him exactly what I would like to do as a volunteer. But for those who know the Prince William Soil and Water Conservation District's water quality program, you can find out for yourself, we've been doing actually very well. But personally, I would like to share with everybody in this room who has concerns or who has concerns about our climate change and the Potomac River, that it was a great challenge for me. There were times that I thought of quitting. There were times that I cried and I asked, why am I doing all this as a volunteer? So I believe with your presentation, a lot of folks in here will learn how to give a chance to those who don't look like, to strangers. And there are people who have that mentality that if somebody that doesn't look like them wants to say something or wants to present something, it doesn't make any sense. But if we learn to give everybody a chance, I always tell everybody that I meet, the most important person in the community that I give great respect to is that beggar who stands by the roadside, because he knows the in and out of that community. And if we can take ourselves to look in that direction, I think our discussions here will make a great difference in the community. Thank you so much.
I think we have time for one more.
Thank you. You mentioned earlier that you said this room understands that climate change has been happening and we've known this for a long time and that the public seems to be catching on to that. I was wondering what your organization is seeing the shift being at the government level at different stages. Like, where's the federal government at and state agencies and local agencies and putting the political will to make change happen? I feel like a lot of that needs to come from those government agencies. So I don't know if you're seeing any trends in that and whether you could talk about that.
Yeah. So are there trends in state, local, and federal government's action on it? It depends on the wind. So I think we're seeing a lot of talk and sometimes commitments, especially on the local level. I mean, if we look at what Montgomery County has just passed in the state of Maryland, to look at the state level, has passed on tree protection. I think that's a huge step forward. I know there's the Moore administration in Maryland has made climate change kind of a central commitment of their environmental work. Now getting those things passed is the next hurdle. We tend to take a local approach, and it's different in Maryland and Virginia, as many of you know, the way that those states work is very different. We tend to take a local approach because we think local change is not only a little bit easier to make, especially if you are really deeply rooted in what communities want, but that it is less likely to be reversed, that course, when you take local action. We then try and work on the state level. And we don't actually spend that much time on federal, partially because we're so focused on our region, but partially because we think long-lasting change is much more likely to happen at the state and local level, and which is why we invest so much time in community building. So it feels like the winds are changing a bit, but it is a hard road, and I think especially at the federal level as things change so frequently.
Okay. Well, thank you very much, Katie. Thought-provoking keynote address. I'd like to thank Blackman. Round of applause. So my final duty in session 1 is to introduce the moderator for session 2, Dr. Chris Jones. Chris is the founder and director of the Potomac Environmental Research and Education Center, PEREC, okay, located on the tidal Potomac River in Woodbridge, Virginia. It's a beautiful facility. I've been there, and it has scenic views of the water. PEREC is home to 8 faculty researchers from George Mason University's College of Science and 3 from GMU's College of Engineering and Computing. Dr. Jones has been a Potomac researcher since 1980 and founded the long-term aquatic ecosystem study that is one of the longest in the world. Chris has received the Jack Wood Award for Town Gown Relations and the Earl C. Williams Presidential Medal for Excellence in Social Impact at GMU. Ladies and gentlemen, Chris Jones. I think this works.
Thanks a lot. So, yeah, welcome to our first session of papers, and I think our keynoter really set a nice pattern for us here with some thoughts at a more global level or at a more comprehensive level that sort of frame the whole conference, because we all know that we have a lot to do, both in terms of technical knowledge, scientific knowledge, but also the piece that's often missing, which is to mobilizing the public and explaining things to them so that they can it can help us, right? And they can be part of the process. I know as a scientist, I've often thought, maybe more in the past than now, that my job was to look at data, do experiments, and try to understand the system, and then make recommendations to decision makers. And of course, they will follow them, right? Because they were well grounded, right? But there's a huge component missing in that process, which is very important, which is public understanding and education, and also just education of our decision makers. So that's why actually in 2000, I founded our Department of Environmental Science and Policy, which seeks to have a dialogue between social scientists and natural scientists, so that, and students are very interested in this, the PhD and master's students. Some would rather just do science, of course, but many are looking at careers in public service, and they really want this perspective and often blend the two areas in their dissertations. So thank you for allowing me to speak about that for a minute. So my main job here is to introduce our speakers. So I guess our first speaker is it Cherie Schultz? Is that right? Okay. I a little need to look over the agenda again. Sorry. So Dr. Schultz is Director of Operations for the Cooperative Water Supply Operations section, Potomac Co-op of the ICPRB. In this role, she provides support to the Washington metropolitan area's regional water supply system, which includes suppliers in Maryland, Virginia, and DC. She is responsible for water demand and availability forecasts for the region, conducted every 5 years, which includes estimates of the impact of upstream consumptive uses and the potential impact of climate change on future supplies. Very relevant to our topic today. She's responsible for the management of our local water supplies. She is also responsible for, reaction, how we react during periods of drought, which we know we can tap into the reservoir upstream. She holds a bachelor's degree in physics from Stanford University, good. A doctoral degree in physics from SUNY Stony Brook, and a master's degree in engineering from the University of Maryland. So without further ado, I present to you Dr. Schultz.
Thank you very much, Professor Jones. So to start out the technical presentations, it seemed like it wouldn't be a bad idea to take a look, just go over quickly what we think is in store for the Potomac Basin in terms of climate. And my group is very interested in this because we need to forecast water availability in the future for our planning studies, our water supply planning studies. I'd like to acknowledge the contributions of other staff in the co-op section, Alma Tusek and Sarah Ahmed, to climate change work. First, just sort of a summary of what I'm going to talk about. Might as well talk about the global context very briefly of climate change and how we fit in, and Potomac Basin projections. And it's as Katie talked about, it's getting wetter on average. That's what almost all the projections are saying now. And the water supply perspective, we need to think about extreme events and including extreme drought. So though the basin is getting wetter on average, there's a lot of indications that extreme drought will be drier. It's hard to make sense of climate change because there are things that we know quite well, but there are things we don't understand. And the certainties temperatures are rising around the world and they're going to continue to rise. Precipitation is becoming more variable. And sea levels are rising. Katie talked about Potomac River estuary already rising to twice as much as global projections. But there are uncertainties that make it difficult to tease out some of the things that we're going to see. For example, how far will temperatures increase? There's a lot of variation and there's a lot of uncertainty there. How will precipitation change in our region? Precipitation is expected to depend on regions. Some regions are on average going to get wetter and some drier. How will river flows respond to the competing impacts of rising temperature in our region, rising temperature and rising precipitation? And how will societies respond to this challenge of climate change? That's a key uncertainty that drives a lot of results. First, just a brief overview of global projections. And here is the famous hockey puck graph. It's probably worth showing, even though I'm sure you've all seen it. Global surface temperatures in the last International Panel on Climate Change report, the estimate have risen about 1 degree centigrade from the baseline period of 1850 to 1900 to the period 2011 to 2020. Global surface temperature projections, they're really driven by how society is going to respond in this coming century. The projections are wide. At this point, the representation of how societies respond is termed shared societal economic pathways. And so you can see projections from SSP1, which is a very sustainable response of global societies to climate change, all the way up to SSP5, which assumes that development is going to occur largely based on fossil fuels. So the lowest projection is that we will maintain the increase in warming to 1.5 degrees centigrade, but the highest projection is that warming will globally increase by almost 5 degrees centigrade by the end of the century, the 21st century. It's true that fossil fuel development is termed by some not the likely scenario because renewables, we're making such great progress on renewables. But if you look at data match of greenhouse gas emissions up to current emissions, it actually follows the highest emissions scenario so far. But of course, we're very hopeful that that will stop. And finally, how does this translate to the hydrologic cycle, which is what my group is very interested in? You can see that precipitation, average precipitation is projected to have different responses in different regions. In our region, it's projected to increase. But evapotranspiration, evaporation and use of precipitation by vegetation is going to increase as well. So that's a competing effect of temperature and precipitation in our area. Runoff or stream flow in our area from this particular global projection is projected to rise, and we find that as well from our more detailed looks at projections. Surface soil moisture is projected to become drier. So now focusing in on the Potomac, and the focus of my group is the freshwater river. River flow down to Little Falls Dam, which is just upstream of Washington, D.C. And that stretch of the river just above Washington, D.C. Provides approximately 78% of the water supply of our metropolitan region. Fairfax Water, WSSC Water, and the Washington Aqueduct provide water to the District of Columbia and the Maryland and Virginia suburbs from intakes located just above Little Falls Dam. So that is our focus point. In our studies, we've been using the annual time step. That's a fairly reasonable time step for water supply planning. We have reservoirs to take care of short deficits in the river, but for a very dry year, it can be a challenge. And the data we've used historical data from Oregon State's PRISM model and future projections from the coupled model comparison project 5. So we haven't yet studied the CMIP 6 projections. As far as temperature, historically, temperature actually in the Potomac, we don't see much of a trend because in our region, temperature was fairly high in the 1930s during the Dust Bowl period, during the Dust Bowl drought, except in the most recent years. But you see the projections, and those are projections of long-term temperature over 30-year periods. Again, they vary widely depending on the greenhouse gas emission scenario. Maybe I'll just say the warming in the Potomac Basin projections is a bit higher than the warming in the global projections, and that's because land generally is going to warm more than the global average. Precipitation, very variable in our region, as you know. And again, this is annual precipitation, so this is changes in yearly average precipitation, but still quite variable. And the projections are somewhat close for these greenhouse gas emission scenarios, but precipitation is projected to rise in the Potomac Basin. And how does that translate to river flow? Rising precipitation is going to increase river flow, but rising temperatures may, in some years, decrease river flow. So we do see in our modeling increases of around 10% in river flow from all the greenhouse gas projections, but those are long-term average flows. What we're interested in, though, are extreme years, extreme drought years, and as long as we were doing extreme drought years, we took a look at extreme precipitation years. So looking at the first percentile years and the 99th percentile years. So the first percentile value years were the very driest years. And how are they going to change? And in our modeling, extremely dry years are going to get drier. So an extreme drought year in most of our scenarios is going to be more severe than a drought that's been experienced in the past. Extreme wet years, sort of the 100th flood year, those years are going to, flow in those years is going to rise. Our modeling depends on the sensitivity of river flow to temperature rise. So we have 3 different scenarios depending on how the river will respond to rising temperatures. Low sensitivity, medium sensitivity, and high sensitivity. And in the medium and high sensitivity scenarios, we will have more extreme drought years. So our results definitely indicate the competing effects of rising precipitation and rising temperature. And most scenarios do indicate that extreme drought will become more severe. That has implications for our regional water supply planning. It indicates that more resources are needed to take care of the fact that droughts in climate change may become considerably more severe. Other uncertainties, we have needs to better understand temperature sensitivity, and our society has a need to avoid the most extreme greenhouse gas scenario. And that's something that we will all be working on. So anyway, thank you very much.
Questions? Yeah. Cherie, good to see you again.
Nice to see you.
I was an ICB Virginia commissioner years ago and enjoyed your work then and enjoying it now. what has been the change in the water temperatures in the Potomac River? I mean, we've seen record temperatures in the oceans off the coast of Florida. Are the temperatures rising in the water temperatures as well?
And that's a great question. And I have seen papers saying, yes, that's the case, but I'm not an expert in that. Hopefully, people will be addressing that later.
Okay.
But so we focus on air temperatures, and rising air temperatures are definitely going to increase water temperatures.
Yeah, that's the key
Yeah.
indicator of a change is coming in the water temperature is rising. So that's what I'm really interested in. Thank you.
That's unfortunate because under our major reservoir, Jennings Randolph, a thriving trout cold water fishery has developed. And I don't know if anyone has modeled yet the implications of that. I think Carlington Wallace is doing some modeling where he may have answers there sometime in the future.
Okay, thank you.
I'm going to touch on that in the estuary in my talk.
We, in our Guston Cove study, it's been 40 years this year. Now, we don't continuously monitor water temperature. Sorry. Our Gunston Cove study has been going for 40 years this year, and we don't continuously monitor temperature, but we do it in the same way we've been doing it every year. And we haven't seen very much change in temperature, particularly in the, in the bay that we work in a little bit, but in the main river, we haven't picked it up. Could be just due to a lack of sensitivity of our analysis. So anyway, anybody else with a question? I think we have time for one more. If I will just jump in with one, then is so in the data that you showed, Cherie, there were the actual data points didn't seem to show much of a trend. So it's mostly, any trend is mostly based on the modeling, right? I mean,
You're right. Yeah. The Potomac seems to be an interesting transition region as far as flow. USGS studies have shown that north of us, a lot of flow metrics are rising, and south of us, a lot of flow metrics are falling. So we don't see strong trends in the Potomac yet in terms of river flow.
okay. Thank you very much, Cherie. Appreciate that kickoff for the for this session. So let me get my. Our next speaker is Dr. Nathaniel Hitt, who goes by the name Than. He is a research fish biologist at the USGS Eastern Ecological Science Center in Kearneysville, West Virginia, which is a really interesting place if you get a chance to go there. And for many years, I didn't know about it, but once I got there, it was really very interesting. So his research investigates freshwater fish ecology from a landscape perspective, which of course is very relevant to our watershed perspective, focusing on stream ecosystems in the Appalachian Highlands. So Dan, thank you.
Okay, thank you for being here. It's good to be here this morning with y'all. Let me first start by addressing this question. USGS has looked at water temperature in the main stem Potomac. It's increasing. So Rice and Jastrom is the paper. I can provide that to you. Also, we have some other work ongoing which suggests the same thing. So we're really confident that water temperature is rising. But I wanted to talk about the fish world today. And let me start by just giving you my motivation for why I think there's a story to tell here. And I'm going to ask for your help because I don't think the story has been told. And that's where I need your help to help tell this story. My work at the USGS and at the Eastern Ecological Science Center in West Virginia, and I have the privilege of running an experimental stream lab where we do manipulative work looking at cold water fishes, but also main stem river fishes and the community of fishes in there. My motivation for this, in this investigation, it's several fold. It starts with this. There is a deep, deep sense of history in these fishes, in the story of these fishes. Okay, we may be on autopilot here. I don't know about this. Whatever. There's a deep evolutionary history, millions of years of evolution Millions of years of evolution have gone into the strategies for survival and reproduction, and we can learn something about the status and trends of our water resources by looking at these fish that have adapted and survived for millennia, millions of years. Keep in mind that, fishes were on the scene millions of years before flowering plants, millions of years before birds. I mean, I'm on the board of Audubon. I don't want to throw any shade at bird people. You get in trouble for doing that. But it's an ancient legacy. That's what my point is. That's motivation number one. Motivation number two is this work connects to people. I mean, Katie Blackman just laid it out there very clearly. I think we need to be thinking differently about how we connect with people in these resources. And I would offer this thought that when we think about how we're supposedly so divided in the world, red, blue, right, left, et cetera, think about fisheries. Fisheries bring people together. Fisheries transcend those political boundaries. It's not interesting. What's interesting is what's on the river. What are you catching? What are you seeing? That's interesting. And that's one of my motivations for looking at this from a research perspective, because I think it connects us with people. Okay, I'm going to throw a concept at you, and then we're going to use this concept to understand whether the community of fishes in the Potomac is changing and how it's changing and how do we interpret this. This is a concept that I really like this. It's very powerful. It stems from marine biology, freshwater fish biology. It is a universally relevant premise or a concept that you can take with you and use in many different ways. It's called life history theory. And you can think of that as a triangle. It's all about trade-offs. Each one of these endpoints of the triangle would kind of represent a stable strategy for survival and reproduction. It's worked for millions of years, okay? Millions of years. So one strategy would be the delay maturation strategy. This would be American shad. Grow to a large body size, delay maturation, and when the time is right, spawn. That's a periodic strategy. Here we have an equilibrium strategy where it would be few eggs, big eggs, parental care. So this requires stability in the environment. This is the human strategy. And then we have a killifish strategy. This would be the opportunistic strategy. I mean, people might refer to this as weedy species. I think that's kind of pejorative. Look, they've been around for quite a long time. Thank you very much. Longer than humans have. So we could think about that as a framework, the live fast, die young strategists. So changes in the relative abundance of these different kinds of functional groups can tell us about changes in the condition of the Potomac River. This has been applied globally, but our work is some of the first to apply it in the Potomac River, and we were able to do so with colleagues from Maryland DNR, fantastic colleagues who have done many years of work to understand this. So we're really blessed to have excellent data to answer this question. Okay. For the purpose of today, we can interpret this framework in the context of flow regimes, okay? Flow regimes, because flow regimes are what drives the success or failure of these different strategies. The stability and seasonality of flows. So we know this. Work that's been done globally and across the US, if you put a dam in, you see predictable responses to flow stabilization. You see more equilibrium type species show up, and you see fewer periodic or opportunistic species. And many times those are native species that are declining when you put a dam in. That's a response to flow stabilization. We see that in the Southwest very clearly, for example. Of course, as we just heard from Dr. Schultz, extreme flows are highly relevant here. Extreme flows are predicted to increase the amount of opportunistic species that live fast, die young, extreme conditions. They thrive under those conditions. So both on the high flow side and the low flow side. Our interest in the high flow side really comes down to the biology of the larvae and the juveniles and the eggs. It's much harder to get out of the way of an extreme scouring event when you're a larvae or an egg. So to the Potomac, here, we've heard that there is some storage on the Potomac, of course, we know that, but there's relatively little storage in the grand picture of things. So the flow regime is fairly natural. When you look at all the big rivers on the Atlantic coast and across the US, the flow regime of the Potomac is relatively natural. USGS has shown this in our flow gauging work. And so this gives us an important opportunity, not just to understand the resources and quality and water security of our region, which of course we care about, but also to say something about the condition of the natural landscape across the US. So the Potomac is relevant for understanding climate change broadly, okay? And it's also a fantastic place to do some fishing. So, the natural flow regime gives rise to natural habitat features. This is the Needles section above the Dam 3 pool, the Harper's Ferry area, the confluence of the Shenandoah and the Potomac. And you can see these features, and they're only there because we do have a fairly natural flow regime. That makes it interesting from a biological perspective. Of course, we see high flow events here, some extreme high flow events, which, at some level is a natural phenomenon, gives rise to habitat. Here's Great Falls, the Potomac. But let me highlight something that Dr. Schultz has said here. It's extreme weather. It's interesting from a biological perspective, not so much that there is an extreme event. What's interesting is the sequence of extreme events, or the periodic nature or the recurrence interval of these extreme events. We've done some work, modeling and simulation of brook trout population dynamics in Shenandoah National Park, another great resource in our region. And we can show that if you have a high flow winter every 5 years, well, you'll see stability, right? They can deal with it. They've dealt with it for millennia, no problem. What's the problem is when you see a high flow event in the winter every single year, these species spawn in the fall, so their eggs and larvae are subject to high flow events over winter. Unlike most of the other fish that spawn in the spring, right? So the point is this. It's not so much the presence of an extreme event, but it's how they're packed together in time. Are rare events becoming common? And that's what you predict, right? Okay, so let's look at the Potomac with this long-term data set. We're going to look at this with respect to flow requirements, this life history strategy, and we're going to ask the question, is this random or is it explainable? The data set we'll be looking at is from Maryland DNR, and I really have to give credit where credit is due here. Their effort they have spent to identify these fish over 40 years is really profound. It sites all up and down the river. I'll show you a map. So we're going to look at some modeling, and we'll ask the question about random and non-random changes in life history strategy. Here are the sites that DNR has sampled for many years, and each one of these sites consists of seine hauls. They consist of identifying all the fish. Now, keep in mind, this is an index of juvenile fish abundance. No self-respecting adult muskie is going to get caught in a seine, but their larvae might, their juveniles might. Okay, so this is an index of juvenile recruitment. Here's an example of that kind of seine haul. There's this juvenile smallmouth bass there, seam. These are the kind of fish that we're looking at, and that's an index of the total population. Just keep that in mind. Okay, so here's basically what we see. The leucicids, formerly known as cyprinids, the minnows dominate the assemblage. That's kind of expected. But we do see a diversity: centrarchids, the sunfishes, the catfishes, also the darters are present. So this is kind of an expected distribution of fish. Note that there are over 250,000 individuals in this data set. This is big data. So let's look at a couple of focal species, and then we'll roll it up into a general inference. Smallmouth bass. Smallmouth bass, introduced in the Potomac, but widely beloved and an extremely important sport fish for our region. And what we see is that we lack the recruitment years. We're not seeing big numbers of juveniles showing up in this latter data after 2010. The way to interpret this, basically, we're looking from red to blue is looking from downstream to upstream, and of course that's over time. Rainbow darter, another species that's new on the scene. Rainbow darter, presumably introduced, and now we see it kind of, welcome to the Potomac. Banded killifish. This is an extremely important one. This is a native fish. Remember, this was the opportunistic strategist. And what we see is that banded killifish, present in the historic data, but now has exploded in abundance and is moving systematically upriver. Put a pin in that. We'll come back to that one. Central stone roller, another native species, a species that capitalizes on using algae, has a modified lower lip that focuses on scraping algae and periphyton from rivers. And we can see that this native species has dramatically changed its abundance over time in the Potomac. So what does this mean? How do we roll this up into some kind of general inference? I'm going to leave the methods out of this, but we've done some modeling looking at change over time. This is a year effect. So what you're looking at here is a temporal trend, the annual change in abundance for a whole suite of different species Whether those confidence intervals intersect that 0 line tells you whether or not it's a meaningful trend over time. And we can see that there are increasers and there are decreasers. And there's some that are random, okay? Increasers included banded killifish, rainbow darter, common shiner, mosquito fish. Put a pin in that one. Decreasing fishes, tessellated darter, bluegill, river chub, smallmouth, bass, creek chub. So those are species stories. Now let's look at the community story, kind of roll those species inferences up to the larger level. And this is a way to represent community diversity in 2 dimensions. So a simple way to think about this is, how close are you in this space? That's how similar you are as a community, okay? So let's put our strategies on here. So we're going to look at maturation length, total length, body size, longevity, fecundity, spawning season length. These are the attributes that we interpret based on this life history theory, okay? And what we see is this. Just to boil it down, there are predictable, interpretable patterns of life history variation in this space, in the Potomac River. We do see a space for opportunistic species, the opportunistic species that are the live fast, die young species, the ones that capitalize on unpredictable conditions, such as unpredictable flows, droughts, and floods. Equilibrium species, we see a space for that. We see a space for periodic fishes. And so we can look at this based on, taxonomic diversity, but that's not particularly interesting. We can look at it native and non-native species. Okay, that's another thing we can do. But here's what we really want to focus on. The change over time, okay? And so what we could do is we could map the change over time as a space based on this fish community diversity. And what we see is a predictable pattern, a very interpretable pattern, which I'll summarize as this. Increasing species in one place and decreasing species in another. And guess what? The opportunistic species are species increasing over time. The decreasing species are the periodic and equilibrium strategists. Translation: if you rely on stable or predictable conditions over time, you tend to be decreasing over time. If, however, you rely on or you capitalize on unpredictable conditions, unpredictable flow conditions in particular, you tend to be increasing over time. These are data from the Potomac. This is our home. This is evidence for a destabilized flow regime in the river. It's a biological evidence. And I'm going to say one more thing about this. It's important because these strategies have been stable for so long. To see them change over the course of our lifetimes is something to really take to heart. Okay, and we also know from USGS increasing spring peak flows are on the rise. That tracks with this biological observation. We published this recently. I'd be happy to provide a copy for it. We also did some work more recently looking at the other side of the coin, the stability associated with groundwater in karst landscapes, carbonate landscapes. So climate change is multifaceted. There's evidence for some stability on the landscape too, not in the main stem river, but in the tributaries that are associated with carbonate limestone. And just to summarize the key result here, if you are in a carbonate-dominated limestone bedrock under a huge aquifer, you're not changing over time. You're more stable over time. And if you're in a rainfall runoff, flashy environment, guess what? Over the last 30 years, you're changing over time. This is amazing to me because, again, these are evolutionarily stable strategies that have been around for millions of years, and we see them changing over the course of tens of years. So here are some ideas. I'm gonna need your help to tell the story to a broader audience in the scientific community, and so I look forward to that. But we see changes in the fish stories of the Potomac. We see that if you require stability, you tend to be decreasing. If you capitalize on instability, you tend to be increasing. So this is a biological lens to look through this, and it supports the notion that the flows of the Potomac are changing. This is a biologically relevant index way to think about the river. So it's, we look ahead, extreme events. This is relevant for us, and I think it's also relevant to when we think about connecting with people, and we think about connecting with anglers and the community at large. So I appreciate your time and attention, and I look forward to the discussion here.
Thank you very much, Dr. Hitt. We do need to move on. Very interesting presentation, though. I know there's my colleagues that are fish biologists are very eager to follow up on this with Dr. Hitt. So our next speaker is Dr. Elgin Perry. Dr. Perry has been around the Chesapeake Bay region for a number of years, decades, like me. His services are much sought after as a statistical consultant. So I'm not going to read, I'm having trouble reading up here anyway because of the font, but I'm not going to read his bio that's on here, but suffice it to say that he has been totally engaged in the Chesapeake Bay restoration effort. And I know he's worked with many people at ICPRB, notably Claire Buchanan. And so I think he's got a real perspective, long-term perspective that can help us to navigate, pardon the pun, through some of these issues. So as soon as he's ready, we will turn it over to him. Let's see. So just to the
Chris. As Chris says, I've been around a long time, and so I've been a consultant to the EPA Bay program since the early 1990s, and in the last decade, we've been working to revamp the Bay program methods for our analysis of trends in the fixed station network. And boy, we are struggling with technical difficulties here. Okay, advance the slide for me, if we can. Okay, so just a quick roadmap. I'm going to be talking, this is basically a methods talk. I'm going to give you a quick introduction to our Bay Trends package, the package that we use for detecting whether things are improving or degrading. And then I'm going to move into something that we do as a kind of a post-trends analysis, where we use clustering methods to try to get a better handle on what the structure is that the trends package is telling us about. And then we'll look at some examples with water temperature, but this is going to be in the Potomac tidal network rather than the above fall line riverine section of the river. So next, please. This is the Bay program fixed station network shown on the left there. And there's a link to the data hub. If you want to download these data, they're out there for you to use. So next, please. Okay, so this is an illustration of our trend model. It's what we call a generalized additive model. So it uses these cubic spline smoothing functions to just think of it as fitting smooth curves to data. I'm going to move over here with apologies to the people on the other side of the room and wave my arms a bit. But the dashed line down the middle, the solid dashed line is you can think of that as a seasonally adjusted trend effect. And then this oscillating line, solid black line that goes top to bottom, is the full model. It reflects not only the long-term trend, but it reflects seasonality. And then we have a component of the model that also allows the trend to change over time. Not the trend to change over time, to allow seasonality to change over time. Or you could think of it as the other way around, that the trends are changing within the seasons. So the different seasonal lines are represented here in different colors. And there are a lot of other details on this that I'm just going to have to gloss over. But if you'd like to get into details, just track me down sometime later today. Next, please. Oops, I lost my slide. Oh, you got it. Oh, okay, thank you. So here's the same model fitted to a longer period of data. And you can see it gets pretty messy looking. You can imagine that as we were sitting around trying to look at these trend models for every station in the river and come up with some kind of general conclusions, that got pretty tedious. And so that's what moved us into this next stage where we started to look at cluster analysis. Next, please. So what we would do is we would take predictions from that model and assemble them into a three-dimensional grid. So we would get a prediction from the 15th of the month for every year in the period of record for each station in the area of interest. and we would assemble those into a three-dimensional data structure where we have years on an axis, months on an axis. So those two together form like a spreadsheet of data. And then if you can imagine multiple spreadsheets that stack up for each station, that's the basic data structure that we're working from to do our cluster analyses. So next, please. So if you know something about cluster analysis, you know that somehow we have to get to a two-dimensional data structure to actually do a clustering. And so here's an example of reducing that, that prior three-dimensional structure to a two-dimensional structure by just simply taking the annual averages over the months. So here, the what I call the items, those are the individual things that are going to get grouped by the clustering analysis. The items here are stations, and each station is described by a vector of annual means, which occur between the years 94 and 99. So that's an intermediate data structure. And by going through these steps, we can look at the data in a lot of different ways that we will talk about as we go through this talk. So next, please. So just a little bit of detail on methods. We use what's called an agglomerative clustering method as opposed to a divisive. So we start with individual items and build them into groups instead of starting with a big group and splitting them down. We use something called Ward's method to form the clusters. You can read about that on Wikipedia if you want to know more about it. And we'll be looking at 4 types of graphical output: a dendrogram, profile plots. We put the station groups on maps, and then we look at something I call the season by station plot. The user of this software has a lot of choices in terms of what months, years, or stations, like what subset of data you would like to look at. You also have choices about whether you want to group years, group months, group stations. You can choose a scaling for the profile. Sometimes it matters a lot whether you're looking at the raw data or you're looking at mean adjusted data. The user also chooses the number of groups to interpret. So let's move along and look at. So with these choices, it allows you to address different questions about the data. So if you're looking at stations as your item and years as your profile, so that's like what we were looking at in the 2x2 table that we looked at just a moment ago. And you can address the question about what stations have similar long-term profiles in terms of the trend. And so we'll look at examples of that. If you then turn around and mean adjust the data, it forces the clustering algorithm to focus much more on what the shape of the trend is over time as opposed to the level of the trend over time. And I think I'm running short of time because of our technical problems, so I'm just going to skip through the rest of these. And let's advance the slide. I don't think. Okay, so here is a dendrogram, and we have stations that are listed along what would be the x-axis and similarity on the y-axis. The clustering algorithm has identified that these stations belong together in a group. These are stations that are just below Washington, D.C. They're in the tidal fresh. The TF stands for tidal fresh. And there's one tidal fresh station, the lowermost of the tidal fresh stations, that got grouped with the river estuarine transition stations. And in the middle here in blue, we have the lower estuary stations. So that's what the dendrogram looks like for a simple analysis. So let's advance the slide and look at the profiles. So now these are the profiles of those different groups. So you can see here that the dashed lines represent individual stations, and the heavy red line is the mean of all those 3 stations that are in the red group. And so we have a similar display for the other 2 groups. And what we see is a pretty dramatic difference between the upper tidal fresh and the river transition stations. Like the upper tidal fresh have a very jagged trajectory over time. Whereas once you get down into the river estuarine transition zone, I think due to just tidal mixing, that heterogeneity gets smoothed out. And in the lower part of the estuary, you see these smooth increasing trend lines. So the gentleman that asked about temperature, is it increasing? I think it's pretty clear that river-wide, in the estuary part of the river, it's increasing. And this, as there's a bar across the bottom that gives us some indication of high and low flow years. So the dark blue triangles are high flow, the red triangles are low flow, light blue is above average, orange is below average flow. And you can see then that it's for the most part, it is flow that is driving the years that have lower than average temperatures in the tidal fresh part of the river. 2011 seems to be an exception to that. That was a high flow year, but had a fairly high temperature. I think that had to do with timing, that in 2011, the high flow came late in the year. It was like a hurricane event. So next slide, please. So we put that on a map and we get to see the spatial extent of the different groups. So again, as I was saying, the red group is up near the fall line, and then the green group is in the transition part of the estuary, and the blue group is in the lower estuary. Between the riverine transition and the lower estuary, there's a big stretch of river that doesn't get monitored. That's because it's in the firing range of the Naval Surface Weapons Laboratory. So next slide. So now that you've seen those three types of output, I've put them together on a single slide. This is the same data being analyzed as in the previous slides, except that instead of looking at observed temperature, I've looked at the observed temperature with the mean subtracted away. And you can see that what happened as a result of that is those two smooth groups that were in the previous analysis got combined into one group. And we still have the three stations up near the fall line that have their jagged trajectory. Next slide, please. So now in this slide, we've changed gears a little bit, and instead of letting the stations, we're letting stations again be the items that are being clustered, but rather than using the profile over years as the trajectory or the information to determine similarity, we're looking at profiles over months. And so we've just, instead of averaging over months, we've turned around and averaged over years and look at average seasonality. And here we can see that the groupings are a little bit different. We have, this time red is being used for the lower estuary, and the lowest transition station got grouped in with those. And then there's the green in the middle, that is the middle section of the river. And then the tidal fresh is the upper section of the river. And when you look at the character that differentiates those, you can see that the blue group reaches its zenith in July and has a nadir in January. So the red group, which is in the lower estuary, is everything happens a little bit later in the year. It seems it reaches its zenith in August and has its nadir in February. So there's a little offset of phase between the seasonality in the upper estuary and lower estuary. Next slide, please. Okay, so now I'm looking at something that might be used to get at another way of getting at climate change effects. And I'm letting the items be defined by individual stations and years, and I'm looking at the profiles over months. And what this will allow us to do is to see whether or not seasonality is changing over time. And you can see that right away with the dendrogram, we have so many items that are being clustered that you really can't make them out. But I've chosen to interpret this as three groups, which is similar to the month cluster we just did. I had three groups. Next slide. And you can see the character of those three groups is very much like the character of the groups when we saw everything done just by averaging over the years. And we still have the red group, which has its highest point in August, lowest point in February, and the blue and green groups will have highest point in July and lowest in January. So, and that, could we move to the next slide, please? To make a little more sense of it, I've introduced this kind of a graphic where I have the stations on the x-axis and I have years on the y-axis. So the station by year now is defining the individual items that are being clustered. And what we get to see here is whether or not one station stays in the same group from the beginning of the period of record to the end of the period of record. And here, basically all stations do stay in the same group from the beginning to the end, except for this transition station 2.1. And it tends to flip-flop back and forth between sometimes looking a little more like its upstream neighbor and other times looking like its downstream neighbor. But there doesn't seem to be any evidence of a climate change effect on the seasonality of temperature in the estuarine Potomac. So one more slide. So because that one was not very exciting, I've decided to include one more slide with total nitrogen, which does show some changes over time. And here, TF 2.3 starts out looking like its upstream neighbor, but it ends up in a group with its downstream neighbor. And the same thing happens with RAT 2.1. And I think we know pretty much what's going on, the causes effect. Nitrogen is a parameter that tends to get consumed as you go down the estuary. And so the fact that a downstream station is starting to look like its upstream neighbor is a good sign. It means it's having the profile of nitrogen is moving upstream, and that's largely due to the good work of wastewater treatment plant operators. Next slide. So I'll let you read through these concluding thoughts and then open the floor for questions. Next slide. I do a little wildlife photography, and this is my best shot from the summer. Any questions?
Hi, I can talk loudly. Yeah, sure. Great talk. Really enjoyed it. So about 3 slides back, right, you were showing how you have your one station that kind of groups differently depending on the year, but it seemed like it was pretty consistent as to when it was grouping with the blue group rather than the green group. Do you have any ideas on why that might be?
The short answer is no. I did look at that. It did not seem, I thought it would be a flow-driven phenomenon, but it did not appear to be a flow-driven phenomenon. And it's looking through things, I just was not able to come up. It was every 4th year. I mean, it's hard to imagine what that pattern is about.
It's like a longer, like a longer scale climate oscillation, like forcing that.
Possibly.
Okay. Thank you very much. Let's have a hand for our speaker. Thank you, Dr. Perry. Okay, we're going to skip the next talk because the presenter isn't here, but I'm the co-author, so I guess if you didn't come in the next 10 minutes, I will present it. So at any rate, we'll give them a little more time. So our next speaker is Alex Gunnarsson, and he's made his way up here. So Alex is an environmental management staffer at the Chesapeake Research Consortium, which you may be familiar with. This is a group of universities that work together on bay issues. I'm sorry to say my university is not one of them, but we've worked on that. Maybe we'll get there. In this role, he works with the Chesapeake Bay's STAC, STAR team to support modeling and monitoring of water quality in the Chesapeake Bay watershed, in addition to supporting all outcomes of the 2014 Chesapeake Bay Watershed Agreement by tracking their science needs. He has a background and interest in geography, water resources, GIS, remote sensing, and international affairs, a true Renaissance man. In his free time, he enjoys cycling. What free time he might have, he enjoys cycling, camping, hiking, and reading. So let's welcome Alex.
Thank you very much. All right. Hello, everyone. So my job here as one of the later sessions, I'm trying to synthesize a little bit. And that's perfect because we have a synthesis document we call the tributary summaries produced by the Chesapeake Bay Program, which is an interdisciplinary group of researchers, policymakers, managers from all across the Bay watershed. That includes both the state, federal agencies, nonprofits, academics, and others. And so today we'll be talking about the tributary summaries as a tool to communicate water quality changes and to inform management decisions. And I'm presenting this work today on behalf of the Integrated Trends Analysis team. I played but a very small role in this work, so I want to give credit where credit is due to the team members here. And these are people like Elgin Perry, who presented earlier, Rebecca Murphy, Jenny Kiesman, Olivia Devereaux, Mike Lane, Renee Carr, among others. So this is their body of work. And just to give you a summary of what we'll be talking about today, we're first going to talk about what the tributary summaries are. Then we're going to look at the Potomac as an example, as this is a conference on the Potomac. We'll talk about a story map, which we're using to enhance this as a communication tool. And then our next steps. So what are the tributary summaries? At their core, they are a compilation of information by tributary or region on one, tidal water quality trends. So as we see on the left, we have our trends mapped spatially. Then we see the trends over time. And then on the right, we see the status. And we'll go into these in more detail as we go through. We also have watershed characteristics and changes. So that includes the underlying geology, also land use. So if we look at the figure on the right, in gray, we have land use or developed land in 2001 represented in gray. And then what's in red has expanded since 2002. We also have in the watershed characteristics and change the river input monitoring stations and below the rim stations and other information on the flow normalized trends for total nitrogen, total phosphorus, and total suspended solids. And then we also have landscape drivers. So this information comes from the Chesapeake Assessment Scenario Tool, commonly known as CAST, which is our management model. We can see we have best management practices on the left, how they've been implemented. We have land use in the center of this figure. And then on the right, we have loads by source sector. And these tributary summaries cover a wide range. It covers the Chesapeake Bay Basin watershed. So that's 13 tributary summaries. And they can range from the Potomac to a combination of tributaries, which like we might call the Maryland main stem or the Maryland upper eastern shore, depending on the management needs and the trends and the available information. Now that we've talked about what the tributary summaries are, let's talk about who they're from or who they're for. And so I want to give thanks to the University of Maryland Center for Environmental Science for this wonderful figure they have here that has, on the left, we see information density. And then on the right, we see information synthesis. So we're trying to strike a balance. We're coming up one tier above the primary and supporting documents, but we're not quite up there for the highest level. So these are technical documents. They're designed for the management community. They're also designed for local watershed organizations that have an interest in integrating some more of the science and water quality monitoring. And they're also for the federal, state, and academic researchers. And just to give a few examples to this, we've been working with Friends of the Rappahannock to provide them with information on water quality status and trends in their watershed. We've also been co-producing a story map with them to help bring this information in a more publicly accessible manner so they can present it at different events they have. We also have been working with the Chesapeake Bay Program's modeling team to share this with the high resolution Cherie models we're developing as part of the Phase 7 development. And so they're very helpful background information for these groups to have. The where part, you can access this on the Chesapeake Assessment Scenario Tool webpage. If you go to track progress and then follow that down to tributary summaries, you can find all 13 available there. You can also access it via our Integrated Trends Analysis Team webpage. Go down to the tributary summary section. You can also find some of the great work that Elgin has done and other researchers, including the Bay Trends package that he talked about, as well as Bay Trends Map, which is an application. So talking about how to use this information, we see it, like I was describing earlier in those examples, as a readily available background for change over time in tidal water quality observed with monitoring data. And we have these resources to answer a few questions, such as the following, like, have water quality indicators in my river been improving or degrading over time? What should I target to turn a degrading trend around or maintain improvements for future water quality and living resource conditions? And what should scientists focus our analyses on to provide better answers to these questions in the future? And we'll look at the Potomac tributary today so that we can explore that in more detail. So, information in the Potomac. I'll just start off by saying that this report came out in 2020 as data from 1985 through 2018. However, you'll notice throughout that some of these figures are through the end of 2021. That's because since this is a synthesis document, it includes information from our tidal trends and other resources we produce that get updated more frequently. We are currently working to update this with 2022 data, going through USGS review right now. So hopefully that moves along as quick as it can, so we can get that out to the public. And also the tidal trends are under development right now too, and they should be out next month. So the first section are estimated loads. We look at the rim stations here on the right, and we have true condition here, but we also have flow adjusted as well. And looking at the estimated loads to the tidal Potomac, we see that total nitrogen has an overall decline that is significant due to substantial efforts to reduce nitrogen loads from the wastewater treatment plants and from the introduction of the Clean Air Act. We also see that total phosphorus and suspended sediments has an overall decline that is not significant. Just to give you some more information on what you can find and related to trends in the tributary summaries, looking at bottom dissolved oxygen, we have both long and short-term trends. And you'll notice that on the left, we have our observed changes in trends. And on the right, we have our flow adjusted. Long-term, in this case, this is the period of record, 1985 to 2021. For our short-term, that's the last 10 years, we have observed and flow adjusted as well. So looking at those bottom DO trends in the tidal Potomac, we see that in the summer months, it's improving at many stations, but looking at the flow adjusted trends, we see some decreases. And we see that summer dissolved oxygen is really variable. We are seeing degrading trends higher up in the tributary for short-term trends compared to unlikely trends in the long term. Now, we also want to connect that to status, right? We want to tell the status and the trends of the story. So using this figure that one of our colleagues, Chin, has produced, we can look at attainment deficit for the designated uses in the Potomac segments. So we have open water, deep water, and deep channel. Most of these segments here have only open water criteria that apply. If you look at the figure on the right, we see each one of those boxes represents a segment. X-axis is over time, the Y-axis is the percent deficit when it comes to attainment. So if it's a flat line at the top, it means it's fully in attainment for that designated use. If it dips below, that's how much that negative number represents how much is not in attainment. We can then connect that to our maps that we have earlier. So we have connecting those trends to the status spatially, and then over time as well, connecting those segments with our status maps. And so we see that when we compare that the trends in station level dissolved oxygen and concentrations to the computed dissolved oxygen criterion status for a recent assessment period, it can reveal really valuable information, such as whether progress is being made towards water quality attainment in a segment that is not meeting the water quality criteria, or conversely, the possibility that conditions are degrading even if the water quality criteria are currently being met. So this is a conference on climate change, so I'd be remiss not to talk about that explicitly. If we look at what we currently have, we have surface water temperature trends. And this is not that interesting to look at because we see they're going up, right? We see it both statistically, many of these values are statistically significant, especially when we look at flow adjusted. So we're working to update the tributary summary right now. We're adding in more information on climate change, and that includes a new section that has extreme weather and increased precipitation, warming water temperatures, sea level rise, and the connection to living resources. I can't talk about it too much since it's still under review, but here are some figures from other works that have been published that are being included, such as this figure on the right that shows the water quality standards attainment indicator over time. We see it has extreme weather events and other policy changes denoted above. And then on the left, we have that same PRISM group from Oregon State looking at the precipitation data from 1981 to the end of 2020. And we see following that trend line, there is a increase. So we also wanted to emphasize in the Potomac that it's unique because we have an Insights on Change section. If we had all the time in the world, we'd like to do this for all the tributaries as well. But unfortunately, we had to prioritize, and this was one where there's a lot of strong interest. This Insight on Change section tries to pull in additional research to provide further context for the water quality trends and changes that we see in the watershed. And we're seeking to answer questions like, how do tidal waters respond to actions in the watershed? This might be wastewater treatment plant upgrades or the implementation of agricultural best management practices, also known as BMPs. And we had two important findings for the Potomac. That one, local tidal water response to large nutrient reductions is happening, and it's clearly shown with the data. And two, long-term tidal response to watershed-wide nutrient reductions are happening in the tidal waters. If we look at Mattawoman Creek and Gunston Cove, we see this first finding is shown quite well. We see that as these wastewater treatment plant upgrades were put in place, we see a decrease in chlorophyll A, an increase in Secchi depth or water clarity, and an increase in SAV acreage. And this tells us that the investment in large-scale nutrient reductions is successful for improving water quality dramatically in local systems. If we look at the second finding, we can see that tidal nutrient concentrations have decreased at almost all the stations, and that about the same number of Potomac stations improved as degraded for the total nitrogen load. And when we bring in the different source sectors from some of the other literature, we can see that these tidal trends are not just a local response, but have been shown to be impacted by loads from many of these sources. So, conclusion, the data shows that the watershed-wide nutrient reductions have improved nutrient trends in the Potomac, and the data support the conclusion that with more reductions, improvements will continue. So briefly, just wanted to touch on the tributary summary story maps, which allow us to communicate this information in a more interactive format. With the scrolling features that they allow, it can be more of an engaging tool for reaching those who maybe don't have the time or wherewithal to digest a very long and dense report. So we had one produced in 2021 with our colleagues from USGS, but we are creating an updated version. We were thankful to have some intern funding or some funding to support an intern this past summer who reached out to different local watershed organizations to gather their input on what they would like to see in a story map, since we envision them as being the ones to use it the most. So we've been working to co-produce them with groups like Friends of the Rappahannock. And just to conclude with some next steps, we're updating with the 2022 data, adding that climate change section in, currently going through USGS review. And once we have that done for the James and for the story map, we're then going to go through and update all the other tributary summaries. So this is an up-to-date resource that all those across the watershed can use. And here are some references as to what we use today and links that you can use if you want to read more about these story maps or have access to them. You can visit that integrated trends analysis webpage on chesapeakebay.net. So thank you for listening. These trends, I think, provide insight into the status of water quality in the Potomac, and that is something that we should bear in mind as we discuss these implications of climate change. So thanks for listening.
I'll say that worked with Dan for many years and very adept at creating a story. And so, and I contributed to the story to it today. So we'll have to ask you to limit it to 10 minutes.
Wow. How many of you are doing things with the Potomac River for more than 10 years? More than 20? More than 30? Thank you very much. Have you been doing something with the Potomac River, whether it's drinking it or helping it out for more than 50 years? All right. Wow. You all don't look old enough to have done that. That's wonderful. Well, I've been at it for 30 or 40 years now, I guess, and we created the Potomac River's first website way back in the 1990s, and that got me going on a whole bunch of things. So we'll get back to that over lunch. But for now, I'd like to talk about the term oligotrophication, which I have a problem saying, but I think I know what it means. Anyone else familiar with the term? Great. Okay. It's always great to be teaching something. So I want to talk about the oligotrophication of the tidal freshwater Potomac River in a changing climate, and we'll have do it in 10 minutes or less. Here we go. So oligotrophication is basically an ecosystem diet. So it's the opposite of eutrophication a lot of you have heard about today and over the last 10, 20, 30, 40, 50 years. The idea being that essentially we're trying to reverse the damage we've done to the watershed and to the ecosystem through over-enrichment through nutrients. And that can be done naturally, or it can happen through our own activities, such as we just heard about from the Chesapeake Bay program. So I won't go over the details of that right now, but I think we just skipped more than one. Okay, but you recognize the design in various different ways here. Okay, so the Potomac River is, most of you will recognize where we are on this, about halfway down on the left. This is the tidal freshwater portion of the river. It is really unique in the sense that it has some things going for it that other parts of the river don't have. In the summer, it's a lake, and in the winter, or particularly in the spring, it's a river. And so with that ecotone, we have all sorts of interesting things going on here. Makes it bountiful and popular for recreation. We have both food services that we can get from the river, as well as flush services, which is the things we try to get rid of. At the same time, the DC growth impact have been phenomenal. Over in the 20th century alone, we had an over 50% increase in the population of this area of the river. We of course rely on drinking water and hard surfaces to do our business here, and they're diverting flows from where they would go naturally. We have to deal with wastewater farms, lawn feed, and fertilizer that all gets down to the microbes and causes eutrophication. And that's what we're going to try to focus on a bit here today. And then, as was mentioned before, and we'll be hearing out throughout the week, day today, extreme weather surprises are more and more prevalent. I guess they're not surprised if we're prepared for them. So in the Potomac River, in the tidal freshwater river, we can kind of look at certain set of indicators that many of you are going to be familiar with: total phosphorus, total nitrogen, chlorophyll A, and Secchi discs, which is one of my favorites. It's been around since at least 500 years now. Really cheap to make. What I haven't seen many people talk about is that we kind of have thresholds where we can think about, on this side of this, we're doing well, on this side, we're doing okay, and on this side, we're doing poorly. And that's what these numbers are from a lot of scientific evidence, trying to kind of thread them together and have some kind of thresholds, where the eutrophic part is where we feel like there's a lot of microbial activity going on. There's so much nutrients there that we don't have a lot of buildup of our ichthyoplankton and fish and things like that. But it's kind of that microbial loop where we kind of aren't really happy with the way the watershed turns out. And then mesotrophic, okay, we're getting to do some of our sports fishing. We may not have quite as many species as we would have in other circumstances, but things are like, it's a medium level of carbon sequestration and of productivity of our fisheries, et cetera, et cetera. And oligotrophic is where we think we kind of are a target for a lot of lakes, rivers, and streams, where we don't have too much extra nutrients we're introducing at all. We don't have a lot of extra sediments that are causing problems for the submerged aquatic vegetation, et cetera. And that's has its own kind of threshold there as well. And so what I wanted to ask myself, I'm using data that's available on the Chesapeake Bay Net, as well as data we have at George Mason, is, well, like, where are we on this? We've been working on this for 10, 20, 30 years. And I really want to be able to give a short story. And of course, the short story is 10 minutes, but it's still a little bit complicated. And the gist of it is basically that we're aiming for oligotrophic, but we haven't really crossed the thresholds that we'd expect for that yet. And in particular, our chlorophyll A, which is a way of measuring the algae in the water that lead to algal blooms, we're kind of in the medium area of that since 2010. And before that, we were pretty much in the danger zone. And then for almost all of the other indicators I mentioned, we're still in a eutrophic circumstances. So as one of my colleagues said about 15 years ago, I was quoting Smokey the Bandit, we have a long ways to go and not enough time, short time to get there. So that's kind of the story that I think the TRIB strategies we've heard about are dealing with. But hey, I'm going to be around for 30 more years, so I'm hoping to see some progress as well. And in fact, two of these indicators, total nitrogen and Secchi depth, would be considered hypereutrophic, meaning it's really, really beyond natural circumstances. So if we look at this in terms of different segments of the tidal river, starting up at the Great Falls and coming down to Indian Head, which is just a few miles downstream from here, going from your left to your right, We can see the second depth, the second depth, how far you can see to see your white shoes underwater, or if you're using the second disc, how far you can see that underwater. It's been under a meter for the most part, and that's not exactly where we want to be. So the bottom three panels there are from the upper Potomac, freshwater Potomac, think Woodrow Wilson Bridge and upstream, and the top two right there are from further closer to here, and on Indian Head and Doe Creek. And what you can see, it basically is that everything's been kind of up and down from a day-to-day basis, but we haven't really gotten better, and maybe not gotten worse either. So Secchi depth, great tool, but it hasn't really shown us a lot of progress over the time that we've been involved. For total nitrogen across decades, these little box plots here are going from 1980, 1990, 2000, 2010, 2020. And what you'll see is that we kind of peaked out at 1990, and then what happened right after that? In the mid 1990s, we put some major money into the wastewater treatment plants in DC, as many of you know, and that had a major impact. So these are stations that are located just upstream and downstream from the wastewater treatment plant at Blue Plains, and we can see there was a lot of substantial decrease. And then we kind of stepped down a little bit further. Those medians, which are in the middle of the boxes there, are indicative that we've kind of, we're going down a little bit, but really not this kind of jumps down or leaps down that we expect, given the strategies that many of us have been working on for 10, 20, 30, 40, 50 years. You want to see it go like off a waterfall, not just kind of gradually step down. The story for phosphorus is kind of the same. Yeah, we're a little bit higher in the 80s and 90s, and we're lower now. Now, this is a log scale, which means you get an order of magnitude change. You go from 1 to 2. That would be 10 times larger. But nonetheless, we're not seeing this sort of profound jumps to different numbers that we might have thought after all the time we've been studying on this. We're kind of gradually coming down to hopefully a smooth landing. I would note that there are still some times, even in the 2010s, where we saw some very high levels of phosphorus in our water, ambient water. And looking now at algae, at chlorophyll A in particular, again, this peaked out early on in the 1980s and 90s. And we've been stepping down. So this seems like something a lot of us have experienced. If you've been in the watershed, you kind of expect that something major would happen, but it is major and it's happening. It's just not happening at the speed and the volume that a lot of us might want to have happen. And so I'm thankful for every one of you who's volunteering or working towards those goals. Now, another thing I think about is, okay, when we're thinking of total phosphorus, how does that relate to the chlorophyll A? So when we have so much total phosphorus available, then the algae won't necessarily be constrained by it, right? And so if we see a line where they're somewhat connected together in a smooth line going from bottom left to top right, such as on the second level there in the center, it indicates that the algae are responding. There's not enough phosphorus available. They're basically constrained by that, and we see that happened a lot more in the 21st century, which is the second line column, than the 20th century. Almost done here. We can get more complicated about this, and it turns out that there's some relationships with water temperature as well as with flow, and those are two things that we expect to be influenced significantly by climate change, as was spoken in our last presentation. And so I kind of end with the following thoughts. The tidal freshwater Potomac has progressed towards oligoeutrophication. We're going in the right direction. We're not necessarily going there as fast as we want to. It's gradual, it's sustained, and it's steady. But there's not any irreversible declines where we've really made a huge difference that's visible in terms of like 50 or 80% change in something, for example. These declines aren't necessarily irreversible, and particularly we could think back to July 11th, 2011. If anyone was on the water that day, we had lots of microcystis come out, which is a harmful algal bloom, and it was through the roof. And the circumstances were hot, soupy, dry conditions, and as long as it stayed like that, we had this microcystis bloom. And not until a tropical storm came through about a month later did it all dissipate out. So that's just the sort of weather event we were just hearing about a few moments ago is what we can look forward to causing these sorts of blooms in the future. Even if we're doing the same gradual declines, there's stuff in the sediments, there's stuff in the watershed that will come and cause some challenges. So the last 2 points here, as predicted for our region, these weather patterns are extreme extreme hydrological events. If more prevalent, may slow down or even reverse the harder success we've had here today. So Be prepared. We can't control for all of this, and it's going to be a challenge moving ahead. And finally, we need to better understand and adapt to the role that carbon dioxide, methane, and nitrous and N2O gas may play in our watershed and a global sustainable development success. We're going to have to deal with the issues that we have locally. At the same time, we're dealing with global challenges of global climate change. Thank you very much. I hope it was helpful and interesting.
Thanks. Okay, we move into our next section. Our next section is entitled Regional Resilience. And I'd like to introduce the moderator for that session. Pam Kennel is the Executive Director of Planning and Water Resources for Loudoun Water. She's responsible for long-term planning, development of new programs, and coordinating strategic issues relating to water resources, research, and regulatory compliance. Pam previously served as a consulting practice leader for water resources and sustainability issues, working with water utilities across the United States. For the Washington Metropolitan Area Water Utilities, Pam managed the 2016 Assessment of Water Supply Systems Redundancy and Resilience. Ladies and gentlemen, Pam Kennel.
Thanks, Mike. Does this work? Hey, good morning, everybody. Those of you who have worked with me on some of our water supply issues know that resilience was a big topic, continues to be a big topic, and the regional water utilities continue to try to come up with alternatives to help the Potomac be an even more resilient water supply system. So we're not going to talk about water supply now. We are going to move to a stormwater topic. And I want to introduce a couple of our speakers here. Anouk Santo is a principal and senior water resources engineer with Limnotech. She lives in Washington, D.C., close to the Anacostia River, and has been supporting DOE's MS4 program for the past 10 years. Her professional experience is primarily focused on water quantity and quality issues in urban watershed settings. And with her is Matt Gallagher. Matt's been serving as the Planning and Reporting Branch Chief in the Water Quality Division at DDOE for the last 3 years. In this role, Matt oversees administration of the district's MS4 permit and state revolving fund programs. So let's pass it along. Great. Thank you. Thank you for that introduction. So I'm Anouk Savino, and I will be kicking off this presentation to describe the climate drivers and expected impact to DC's MS4 system. So MS4 is Municipal Storm Sewer System, just a stormwater system of the city. And then I'll hand it off to Matt, who's going to talk a little bit more about how the stormwater program is adapting to and preparing for climate change. So here's a quick overview of that, our presentation. Again, this is all about how DOE is trying to better manage the stormwater program and how they're trying to stay flexible. So as we learn more about climate change impacts, or as climate change invariably will evolve, how the MS4 program can also evolve and adapt. So I thought I'd start with a quick overview of the DC MS4 program and the spatial extent of it. So on this map, the orange shaded part is the MS4, the stormwater, the separate stormwater system. The gray area in the middle is the combined sewer system, which is managed by DC Water and kind of has its own set of issues and concern. But so we're focused on the stormwater system. It's about 31 square miles, just under half of DC's total area. It's about 51% impervious, and that is growing every year. We've got three main streams, about 100 miles total, but the Potomac, Rock Creek, and Anacostia River are the three primary ones, with lots of small tributaries flowing into those, and then everything goes into the Potomac and then down south through the Chesapeake Bay. So one thing that's kind of unique about the district is that there are many total maximum daily load studies that have been done for DC that help regulate the amount of pollutants that can enter that those different segments, different river tributaries. And so those TMDL set water quality targets for a variety of pollutants. Sediment and nutrients are, of course, the ones we hear a lot about, driven by the Chesapeake Bay program. But then DC also has a lot of water quality targets called waste load allocations, WLAs, for metals and toxics as well. DOE, the MS4 program has a consolidated TMDL implementation plan that we updated last year that details how the stormwater program is going to meet their water quality targets and all the different programs that they have in place to get there. And then to tie it back to climate change, DOE has currently, they're waiting on their permit. It's a draft permit currently. And that permit has some climate change elements to it. And those also aligned with the mayor's overall climate ready DC strategy. All right, so DC is subject to 3 major climate drivers. I feel like we've already talked about all of these, so maybe a little bit redundant. But we're looking at increases in precipitation, both in terms of overall volume increases, but also in intensity of rain events. We're also looking at impacts from sea level rise. So the Potomac and the Anacostia are tidal all the way up into DC. So sea level rise and higher tidal amplitudes, bigger floods do have a big impact on the city. And then temperature, which we've talked about previously, both air temperature and water temperature increasing. We have more high heat index days, more frequent drought conditions. So this is what we know is currently happening. It's going to continue to happen. It might get worse. So how do we think that is going to impact the stormwater program specifically? So for one, we expect a lot more stormwater pollution from the increase in rain and precipitation. So that means that overall as a program, we'll need to do more to meet our water quality requirements, our TMDL requirements. And then the other thing that means is that it might, if financial resources don't change, it might mean it's going to take longer to meet those TMDL requirements or water quality requirements. And in the consolidated TMDL implementation plan that we published last year, we ran a couple of model scenarios that looked at different assumptions related to climate change projections, related to the rate of BMP implementation in the future, BMP efficiencies. All these things can be impacted by climate change. And then looked at what impact that makes on when we could expect to meet our water quality targets. And that span, all right. So let's move on. So another impact that we see to the stormwater program is related to more inland shoreline and flash flooding. So with that will come more in-stream erosion and again, more pollutants that will enter the storm system. We also know that most of our existing storm and green infrastructure was not designed with these climate change projections in mind. So that might impact how efficient they are in the future. We also know that the flooding could impact our ongoing monitoring efforts in the streams, as well as our stream restoration efforts. So all of this together, again, is going to impact meeting our water quality targets and the timeline by which we attain those targets. And then related to temperature, so with the increase in temperature, we expect a more kind of extreme and hostile environment that will put a lot of stress on vegetation, and a lot of the green infrastructure that is going into the ground relies on that vegetation to perform effectively. So our green infrastructure could potentially fail or could be less efficient than originally designed. We also expect a potential increase in invasive species. And again, that impacts meeting the district's permit targets. So for example, our tree canopy targets could be impacted by that. And again, it could also impact our timeline for meeting those water quality targets. And I guess, so with that all in mind of all the things that we are seeing coming at us, how does the district then adapt its program to respond to that? So I'll turn it over to Matt for that.
Thank you. So we don't have a lot of time to talk about the ways that we're considering climate change. So this is pretty high level. So next one. There we go. So there are 4 key elements that we are focusing on currently that I'll describe in more detail in subsequent slides. Basically, we're looking at assessing and updating our stormwater design standards, looking at our design support systems and tools, looking at our financial investments in targeted areas, and bolstering our partnership outreach and communication strategies. So one way that DOE is looking to future-proof our storm sewer system is by reassessing our stormwater design standards. So our current design standards are to retain the 1.2 inch or 90th percentile storm, and with retention, think infiltration for water quality treatment. We also required detaining the 2-year 24-hour storm for water quality protection of our streams. And again, detention, think like sort of holding that volume of water for a period of time to help with flooding. And then also to detain the 15-year 24-hour storm. We're particularly looking at reassessing our detention requirements because those are some of our older stormwater standards and are based on some of the older rainfall IDF curves, intensity, duration, and frequency curves. And some projections that we've used from NOAA are showing that we're looking at 12% and 17% increases to our 2-year and 15-year storm, 2-year and 15-year storms. And so we're working with our sister agencies to look at rethinking those design standards so that we can develop solutions that both protect our residents and that also are acceptable or manageable by the regulated community that install a lot of these BMPs. So another way that DOE is looking to build a more resilient MS4 system is by incorporating climate change in our design support systems, models, and tools. First, we're looking at assessing and adapting our monitoring programs for changing conditions. So for example, we're finding it a lot harder to accurately predict and then therefore sample for our discharge monitoring events, which are required through our MS4 permit. So we're gonna have to start thinking about how we can redesign that program to be more successful, that we can catch enough qualifying events. DOE's also been building a integrated flood model, which will, help assess problem areas, create some updated flood maps, and allow us to target infrastructure investment in at-risk areas. It'll also help us look at areas where we can think of like dual function BMPs that can help with flood mitigation as well as water quality treatment improvements. We, as Anouk mentioned earlier in our TMDL implementation plan, it's up on my screen. They're just words. I can keep going in the sense of time. So again, we were mentioning that there's climate change impacts to our TMDL implementation plan model that's may make it a lot longer for us to achieve our water quality targets. And then lastly, we're staying current with technological advances So considering things like real-time control of green infrastructure that would help optimize holding of that water and treatment of that water. I'm going to keep going. No, you're fine. We're also thinking about targeting our financial investments in areas that are most at risk. There is a table. One more. There we go. Yeah. Always have a paper copy. The table on the right is the amount of money or the major funding sources that we identified in our implementation plan update for direct investment in BMPs. So we are considering, how we can best use this money to target at-risk areas. As Anouk also mentioned, that we're anticipating a new MS4 permit in the near-ish future, hopefully. And it's likely to include a requirement to develop a diversity, equity, inclusion, and justice strategy for the plan. We're also continuously looking for opportunities to invest in the highest efficiency green infrastructure, as well as optimizing and exceeding our own retention standards for projects that we do internally. We're also adopting nature-based solutions that can offer multiple co-benefits, not just things for water quality treatment. So think trees are good for heat island impacts and that kind of stuff as well. And then that also includes promoting pre and post-construction monitoring to assess and understand those types of multiple co-benefits best. Will this work? Okay. And lastly, it's really important for us to consider partnerships because the district's land ownership is really diverse. In the MS4 area, 56% of our property is privately owned, 25% is federally owned, and only 6% is district owned. So we really need to have, this is a very small subset of our partnerships, and we really need to have everybody in this with us in order to achieve our goals of having swimmable and fishable waters. I'm just going to stop there.
Thank you. A round of applause, please. We've got time for a question or two. Somebody have a question? Yeah.
Thank you. Oh, this is Susie Burdell, and I work with Virginia Department of Environmental Quality, and my program oversees the stormwater plan thing. And recently they are I think it's been a while that they are trying to update the erosion and sediment control handbook. So are you guys looking forward to do anything in terms of the regulation and policy labor, or not? This is, or you are trying to work on something else like what I saw in your presentation? And the recommendation, yes. Mm-hmm.
I don't know that we're looking at any erosion and sediment control updates right now, but it's a great question. And maybe if you find me later, I can do a little bit more digging to see if I can look into that.
In terms of regulations in the MS4 and other program?
Any other regulations? I think like a big component of our program is adaptive management. And so I think we're probably going to continuously looking at, updating different regulations over time. And in our 2020 annual report, MS4 annual report, we looked at 4 different potential regulation changes, and then the detention standard increases or changes were the most pressing one that was identified. The others may follow eventually, but we're not there yet.
But that was very interesting. Thank you for your presentation.
Of course.
All right. Thanks, guys. I'm going to go ahead and introduce the next speaker and cross my fingers. Susan Minnemeyer is an environmental consultant and founder of Nature Plus with more than 25 years of experience in geospatial analysis and research, supporting forest conservation and improved land use planning. In 21 and 22, she led the technical study on changes in forest and tree canopy in Maryland. Also, Susan spent 4 years with the Chesapeake Conservancy, where she led the Conservation Innovation Center and developed an organizational climate strategy.
Great, thank you so much. Happy to be here today. And I'm going to move our discussions to land. So in focusing on forests, there's the recognition that forests play a really important role as green infrastructure to protect water quality and also water quantity. And increasingly, greater interest in those other co-benefits. I could quote Matt's presentation, but a greater sense of urgency with the role that forests play in strengthening climate resilience and adaptation, but also in mitigation as natural climate solutions. Okay, great. Yeah, I can actually just do it with the keyboard. Okay, so the Maryland Forest Technical Study, it was conducted using data that's available for the whole Chesapeake watershed. It was called for in the state legislature, so we were focusing on some specific issues of high interest in Maryland. So we wanted to measure forest and tree canopy extent, but also leverage new high resolution data to be able to look at regional patterns and address additional issues. So we were looking at forest health, particularly through the lens of invasive species and fragmentation, how the state was doing on meeting Chesapeake Bay program restoration goals, then measuring change over time, and progress in terms of some of the other goals around protection, and then issues like mitigation, banking, and forest and tree planting programs. So I'm giving a high-level overview of the results here. There's a lot more details in the full report. So this is the most comprehensive review that has been done on Maryland's forests to date. Prior to this study, the main data set used to monitor forests is the Forest Service forest inventory and analysis data that we use for our national forest inventory, and also at the state scale. But there was a lot of uncertainty as to whether or not Maryland was achieving forest goals, and any regional patterns were not clear from the state level data set. So it was particularly addressed at seeing what the impacts had been of Maryland's 1991 Forest Conservation Act. That is a law that requires for any major development in the state that a forest management plan be done, the site developed in such a way that important forest resources are protected, and also provide some requirements for retaining certain portions of forests on site, or if that cannot be done, to mitigate them through either planting on site or off site. And Maryland has further goals. In 2013, the Forest Preservation Act set a goal of reaching 40% canopy cover in the state. As I mentioned, it's really focusing on the loss of forest to development and seeing how the state was doing on reaching Chesapeake Bay Agreement goals. In conducting this study, we used 3 different data sets rather than choosing one. And that's because the data available really meets a number of different needs. And we were also hoping in doing the study that we would reinforce our conclusions if we were seeing common trends among them. So we use the Forest Service FIA data, which is ground sample data for ground plots around the nation, thousands of plots that are visited in person. And it's been ongoing for 90 years and is one of the most robust forest inventory programs in the world. We use the National Land Cover data set, which is based on moderate resolution satellite imagery. And for the first time, this gave you those wall-to-wall maps of where forests occur and how they're changing. And it's been, Lancet data has been available since the 1970s, but in terms of wide coverage and frequent updates, we're looking at the period 2000 to 2019. And then there's a new Chesapeake Bay program, a land cover land use data set. And in the images, I compared and contrasted what you see in the 30-meter data on the center image with the high resolution data on the right. And it has a 1 meter by 1 meter resolution. It's based on the USDA's National Agricultural Imagery Program. It's aerial imagery flown by planes. And getting down to 1 meter, it can measure individual trees, loss of individual trees and growth of individual trees. And it also, really importantly, monitors land cover land use at the scale where we make decisions, which are individual land parcels. Forest definitions are really important and can make understanding the results a little complex. But for the Forest Service data, they're monitoring specifically forests, not tree canopy outside forests. And they require at least an acre in size, at least 120 feet wide, also a minimum of 10% stocking to be considered forest. With the NLCD data set, it is looking with satellite imagery from above for areas dominated by trees. And they can identify trees when they're at least 5 meters tall and 20% of total vegetation cover. And then the Chesapeake Bay program data is modeled, I'll talk while you reconnect that, but it's modeled on the Forest Service data. It has a wider width, which is actually being adjusted. But in terms of the overall results, they should be consistent. So the goal is that you can connect what's happening with the FIA field measured data in such a way that you can get a consistent interpretation of results from the high-res data. And as a result, what you see on the screen here is the dark green areas are those tree canopy areas that meet the definition of forests. And then we have all these light green tree canopy outside forests. And we have not been monitoring these at a large scale with data like this. Up until very recently, the way these trees have been monitored have been more with ground-based surveys like what the district does with their tree canopy inventory. But increasingly high-res data is being produced at the local level. Okay, there we go. Okay, so the FIA data, this is the long-term data set, what's been happening in Maryland. I think this is consistent with what you would see across the whole Potomac watershed. The top line and the green markers are overall forest land, and then they also monitor timberland as a subset, which is managed forest for wood products. But what you see is there's a huge increase in forest loss or a decrease in forest cover after about 1960 with suburbanization and increase in population. And that continues largely unabated until in recent years, it begins to tail off. But it's also note those error bars. Maryland is a pretty small state given the density of sampling locations. And so a lot of this confusion around what's happening with Maryland forests is that the rate of change is smaller than the size of the error bars. This table shows some of the key results, and I'm going to highlight some of the numbers in green. And there's initial looks with the high-res data at a local level highlighted a lot of the issues because these different data monitoring tools can see increasing amounts of tree canopy because of the way they're measured and the resolution. So the FIA estimates 2.56 million acres of forest in Maryland in 1999. In 2001, NLCD sees 2.8 million acres. It can see some of those trees outside forest. And then the total tree canopy, the bottom row with the high-res data, sees 3.1 million acres of tree canopy. But there's two cells right above it break that up between tree canopy in forest and tree canopy outside forest. Tree canopy outside forest has never been measured at the state scale before. And then on the last column, the orange numbers show what the trends are over time. And for this study, the key is that we saw all three of the data sets were showing forest cover and total tree canopy declining across the state. There was a small increase in tree canopy outside forest, but as I'll reiterate later, a lot of that is due to fragmentation of forests rather than tree canopy outside forest increasing. So the fact that we saw consistent trends with 3 different data sets really strengthens the reliability of the study. Okay, so this chart, it's a little complex, but we started calling it the swoosh chart as we were working on the project. This is looking at all the areas in the land cover data that changed between the 2 time periods, and this is using the high-res data, so 2013 to 2018. And if you look on the left-hand side, these are all what the land cover was for all the pixels that experience change. And forests are very dynamic. Almost half of the pixels that experience change were forest and tree canopy. And then in the right column, we looked at what did all those pixels that change become? And development was by far the largest resulting class. There is also some return in forest and tree canopy coming from production, which includes harvested forest and agriculture. But that take-home message of forests are changing more than any land cover class. And when they change, at least, half to 2/3 are going into development. Okay, now I'm going to go into some of the regional results with the high-res data. This shows the regions of Maryland that we used, and zoom in especially on central and north central Maryland. These are the highly populated counties, the most rapidly growing counties following the I-270 corridor and the I-95 corridor. And looking across the state, I think you would expect these results, but Western Maryland has the most forest cover. Remaining very little of that is in forest, tree canopy outside forest. When you get to north central and central Maryland, there's less forest cover, especially related to development, and a large portion is tree canopy outside forests. Southern Maryland, again, has more forest cover and higher tree canopy outside forest, but then on the eastern shore, there's less forest because of the amount of the landscape that's in agriculture. When we looked at change in the regional patterns, we saw forest decreasing in all areas except one on the lower eastern shore. And looking at this a little bit more closely, we do actually, that's the one region in the state where we're seeing transition of agriculture into forest. And we're looking at what is causing that, but one of the factors may be increasing markets for some of those low value wood products that is encouraging some farmers to either let marginal lands return to forest or planting managed forests. And we're continuing to look at that because that's not a dynamic we see in many places, but we see that net tree canopy outside forest change increasing in all regions of the state except central Maryland. But like I said, most of that is fragmentation. There is some, we did see increases of forests in agriculture, which a lot of that is related to riparian forest buffer planning. And in central Maryland, tree canopy outside forest change decrease as well. And I think a lot of that too gets to the shift of new development into already developed areas and ongoing loss. On restoration progress, just highlighting a couple factors. The 2 goals are riparian forest buffers and urban tree canopy. On riparian forest buffers, Maryland's at 58% right now out of 70%. We're actually working on improving those goals because a lot of the eastern shore, their riparian areas are in tidal wetlands where trees wouldn't grow. So Maryland, I think, is doing a little better than those numbers appear. And then with urban tree canopy, as I mentioned, it's the first statewide or baywide change analysis. And there was substantial net loss across the state. In fact, the only major city where we saw gains were in Baltimore, but a lot of that may be related to not so much tree planting, but more vacant and abandoned properties. And then we did see some increases in small urban areas like these towns, Salisbury, Chestertown, Easton on the Eastern Shore, where ag land is becoming residential areas and tree canopies increasing. In looking at changes due to development, we looked at exactly what those transitions were. So forest to developed in the darkest color, the largest areas in central Maryland, and especially, think of locations like Western Anne Arundel County. We're sort of filling in that gap of residential areas between Baltimore, Annapolis, and DC. Tree canopy developed. Think also of some like infill development, like Montgomery County's smart growth policies, but it's still going to clear some tree cover in doing that. And then where you see developed to tree canopy, that's increase of tree canopy. So, when ag lands become developed or when trees already planted grow, and there was really no there was developed to tree canopy, but not developed to forest. Sorry, getting a little confused with my numbers, looking at this sideways. There's a lot of detail in the report going county to county, and we saw Prince George's and Montgomery County leading the county. They also lead the Chesapeake Bay as a whole. And I do want to say that despite these numbers you see here, I know through other work that we've been doing with partners like the World Resources Institute that and the Metropolitan Washington Council of Governments, that Montgomery County has actually decreased their loss of forest by a large amount from what it was earlier in the 2000s. So a lot of data to mine here, and you can also see a lot of variation in where tree canopy is increasing in developed areas. I'm just going to briefly say with mitigation banking, we identified a lot of problems, namely the fees that developers pay to avoid retaining forests, or when they can't plant forests on site, or have been too low to fund a lot of this. And then there's been controversy around preservation banking that's protecting forests in lieu of actually planting new forests, but many of the urban counties like PG County felt that that was really important. So there were a couple years where it wasn't happening. It's back in the new legislation. And we can start there. There's a huge variety of tree planting programs, and the ones that happen directly through the Bay program, like CREP data, I think are the most likely to go into common databases, but it's a real challenge to track these. So the state is improving their tracking as a result of the study. And then just summarizing some of the overall funding findings of the study, we found the rate of forest loss is stabilizing. That rate of loss, the curve is beginning to flatten out. But there was no clear sign at which Maryland would meet goals like 40% forest cover, because we saw it still decreasing. But they did gain 17% in population while forest loss slowed. And I think that's a sign that changes in policies can have an impact despite population growth. But forest loss for development and fragmentation are major trends, especially in central Maryland's high populated counties. And we saw that the state had a significant opportunity to transition from forest and tree canopy loss to gain. And in transitioning from loss to gain, I just want to mention that you have two levers you can adjust. You can protect existing forests, or you can plant new forest. In terms of where are you going to see results the quicker, the existing forest put on canopy area at a far higher rate than newly planted trees. So existing forests are the best way to have growth in tree canopy now. And the newly planted trees, you're generally looking at seeing them really appear in the data 5 to 15 years after they're planted. It's really critical, but it's not going to give you, if you only focus on planting, you're not likely to see impacts from that for some time. A new law was passed in Maryland this spring in April. It's going to take effect in July 2024, and it addressed a lot of the issues. And I think being able to, have 3 reliable data sets reinforcing the trend, that kind of gave the certainty of what the patterns were that was able to lead to the legislation. And State Senator Sarah Elfreth, who's in the center there, was the leader, but many different groups worked together on crafting the legislation, and we were really focused on the data aspects. The main, I know we're over time, but the main ways that the new law is addressing the findings is by adding some stronger forest protections for existing forests, and then having higher mitigation requirements for new development. Generally, the current law, the ratios vary, but they're about a quarter acre of mitigation to an acre of develop. Now they're requiring in most areas of the state 1-to-1. So every acre of forest that's clear, an acre of new forest has to be produced. And I think that's going to disincentivize a lot of the sort of exurban development we've been seeing. And then in the amendments and sausage making of getting the final version of the bill, there were some additions to have smaller mitigation requirements in priority funding areas and for transit-oriented development. And these were really pushed because, we have a housing shortage. We need housing in the right places. And so that gave it broad bipartisan support. And there was a new goal set to achieve forest and tree canopy gain. So that 40% goal is out. It was an arbitrary number to begin with. And the trend is, we felt both simpler to measure and would have more lasting impacts. Anticipated outcomes, as I mentioned, shift in development patterns to more transit-oriented development, denser developments, smaller lot sizes, more multifamily housing. And then there's greater alignment with Maryland's climate planning. We worked with the Maryland Department of Environment on the study. As a researcher focusing on monitoring and data collection, of course, we recommended that the high resolution data collection continue, but this is like the first of many of what's potential in terms of what you can do with this data. And I think the other thing is it gives us much more certainty and ability to quantify some of these benefits. So rather than saying we should protect forests because they're good for water quality, we can get much closer to saying they're this good for water quality, how much, and this is where we need them. And I think that's going to have a lot of great benefits. Some links here. There's a link for where the full study can be downloaded and my email address if you have any questions. Thanks very much.
Thanks. I'm afraid since we're at time, we're going to go ahead and I'm going to pass along the mic to Mike.
Yes.
Before we break for lunch, and catch me if you have any questions during the break.
Yeah, thank you very much. But yeah, we're on overtime here, so want to thank that panel, and we're going to be moving now on to lunch. Lunch is outside, just outside these doors, and then we're going to during the lunchtime when come back in here, and then we'll talk a little bit about Curtis Dalpra. Oh, we're going to do it. Oh, okay. All right. I think that was two. Okay. So we do have a couple of slides to bring up. So as I indicated earlier, this conference is dedicated to our friend and colleague Curtis Dalpra, who joined ICPRB in 1981, who passed away earlier this year, still as a employee of ICPRB. So I like to say he died with his boots on. So for many, Curtis was the public face and a very familiar voice of ICPRB. So as the head of the communications and outreach unit, he was well known. This included all the stakeholders in the basin, be they children, reporters, fishermen, scientists, or politicians. He even touched the group in Japan who care for the Potomac River's sister river, the Arakawa, in Tokyo. At the Arakawa Society's annual conference, which was held in February of this year, shortly before his death, Curtis submitted a paper entitled, quote, "River Swimming is a Tool to Improve Water Quality and Citizen Appreciation." And as the water quality there has improved, a swimming competition will finally be held in the Arakawa River for the first time in 80 years. As many of you know, a swimming event is planned in the Anacostia River here on September 23rd for the first time in many years too. Many of his old colleagues came to the funeral in March in Upper Marlboro and shared stories at a luncheon afterwards. And this is just the tribute that we have just received from the Arakawa Society that documented his support for their work and the exchange of information between the Arakawa Society and the Interstate Commission on the Potomac River Basin. So I'd like to invite anybody who would like to share their stories about Curtis to do so now. I think Dan.
Yeah, is Dan here? Where did he go? Did he step out?
Step out. So anybody want to say a few words about Curtis who known him over the years? Speak now. Oh, yeah. Oh.
I'll say something.
Okay, Renee.
If it weren't for Curtis giving me a chance 7-ish years ago at ICPRB, I wouldn't be in this great room with all these great people and learning all these awesome things. And I am forever grateful for him for doing that and sharing all of his 40+ years of knowledge. And I miss him.
And as people know, he was a golden retriever aficionado, was very much involved in that aspect of the area too. You know, we have these pictures going back to when he joined ICPRB. He was a great photographer, documented the flora and fauna and the beautiful scenery of the Potomac River and Basin. So he was quite a loss, and I wanted to make sure that everybody understood that we really miss him. I think Renee's doing a great job, but Curtis just had the institutional knowledge and connections that one acquires over many years of time, from 1981. So anyway, anybody else would like to say a few words? Dan?
As I alluded to earlier today, I'm a mess. Now, I met Curtis now 29 years ago when the Chesapeake Bay had no websites. And he and I put together the Potomac River Reporter online and the ICPRB's first website. And ever since then, I could not go through Rockville without being invited to sushi. That there would be this little sniffer that he'd have, you know, that kind of said, "Hey, sushi." And so I'd call him up and we'd go have sushi. Along the way, Curtis really established himself as someone who cared very deeply for all the things we've worked on and that I alluded to in terms of caring about the Potomac, caring about people in the Potomac and everything else. And yet he managed to do it in such a way that it was both sophisticated, a little bit rebellious, and always witty and entertaining. And one of the things I really find really special about him is that he always found a way to kind of look at the sardonic or kind of twisted, funny way of things and bring it out in a way that didn't hurt any feelings, but really made you aware of some of the dysfunctions we've dealt with in the society. And most importantly for me, he and I shared a love of Japan and Japanese food. And most people would stop right there, but he went ahead and worked with the Arakawa Society to set up a Sisters Rivers program. Has anyone participated in that Sisters Rivers program? Let me tell you, you have about 30 friends in Japan that you didn't know you have. And they love you. They will show you all over the Arakawa River that goes from Tokyo up into the mountains, just like our river here does. And they adopted me as a friendship ambassador from the Potomac Sister River while my wife is doing Fulbright there. And that was all because of Curtis. In fact, he's like, hey, you should go there and just have fun, and they'll show you around. And up until today, they're still inviting me to things in Japan. So I encourage you all to take advantage of that and really think about the spirit of Curtis Dalpra, which was someone who always wanted to make the world a better place without letting you know that he was doing it. He's kind of like, I'm chill right here, but he was really doing some wonderful things for all of us. So thank you. And I'm happy that we had some time to celebrate his wonderfulness here. Thanks.
Thank you, Dan. Okay. Anybody else? Yes.
I'm Nancy Rafiki with the U.S. Geological Survey and George Mason University. And Curtis, in the 80s, he's rebellious, you're right, and he's inventive. And before we had aerial photographs of submerged aquatic vegetation around the Chesapeake Bay, Curtis took me up with his friends from the DC police. We took the doors off the helicopters, and when we had discovered hydrilla in the Potomac, he took me up with his colleagues, and we were able to get photographs that way of this new invasive aquatic plant, hydrilla. He was very involved in all of that, and we kept in touch. And when the new invasive aquatic plant, water chestnut, came into the Potomac River, he brought his camera and his video equipment, and he and I monitored the behavior of waterfowl with the water chestnut plants, and we found that the Canada geese were eating the water chestnut seeds, and he got some fantastic photographs of all that, and it took a lot of his time to work with me on that, but he just got so involved with all of these things, and he was a renegade and a great inquisitive scientist.
Thank you. I think we have time for one more before lunch.
I knew Curtis for a long, long time. And during when the ICPRB used to organize the Potomac River Sojourn, and we had a few days in that trip, is when I got to know him even better. And we sat down, and what I admire in him is his international spirit. We sat down and talked about beyond the Potomac. We talk about the River Nile and all these his international knowledge is most remarkable to me. And thank you. We will remember you and honor you. Thank you.
Okay. Thank you very much for those touching remarks. He was quite an individual, touched a lot of lives, both here and abroad. So with that, I'd like to invite you all to lunch.